Check, check, 1, 2. Morning, everyone. Welcome back to the Cisco U Theater. First of all, thank you for quickly making it back here after the keynote. Appreciate it. Wasn't sure how many of you would be here with me this morning. We just heard Chuck talk during the keynote a lot about AI and assurance and cloud, and there'll be none of that here this morning. I just tweeted, we're kicking it back to old school, going back to hang on. So obviously I'm talking about spanning tree, little classic layer 2 stuff. I'm super happy to see you all here. I did this session in Amsterdam and we had a good time with it. Bit of a laugh, bit of learning, mostly a lot of laughing though. Maybe I'll start with this. So I'm Canadian, so I'm thinking I should hand out some maple syrup candy. So this is third year that I do these sessions at Cisco Live, and I traditionally bring a kilo of candy with me from Canada. So I've got some with me. I'll be walking around asking questions. You get the answer, you get a candy. This is like liquid gold, but in solid form, so it's absolutely lovely. Scott, you can't have any. He's from Canada. So if you're from Canada, I can't give you any because you can go back and get some from the source directly. Right, so my name is Gargano. I work for Learning and Certifications. I'm part of the content development team, so we work on building all the content that's in Cisco U. So all the course content that you would consume on Cisco U, and the courses that you would have taken maybe with an ILT provider, so like Global Knowledge or a Fastlane or a Skyline or a Sunset. So all of that content, we create that content. I'm part of the enterprise team, so CCNA, Encore, NRC, SD-WAN, all the enterprise stuff, that's our team. So obviously I like talking about stuff like this. Been around for a little while now, so this is always nice to talk about a classic layer 2 protocol. If this isn't working, your AI is not going to work, your assurance isn't going to work. You get the idea. I'm going to have some prizes also to give away at the end. So Scott's given me a couple of copies of his CCNA Portable Command Guide. So if you're struggling a little bit with the spanning tree this morning, I'll be very happy if you win one of those books. This talks a lot about spanning tree. I brought my Encore prep book. What I'll do for that one, though, I would really like that one to go to someone who's actually going to be taking the Encore exam soon. It's a 31-day kind of exam prep guide. So what we'll do for that one, we'll do a little raffle for those of you that are planning on taking the exam in the next month or two. Maybe we'll do that at the end on the side. That's OK. All right, so here we go. We'll start with some candy. So what's the point of spanning tree? Right? So you're talking to a colleague, you're talking to your mom. Spanning tree does what? Thank you. There we go. See, easy answers here, right? I don't want too much. So spanning tree. Go. Spanning tree. Spanning tree, what's your, no one wants a candy. Oh, fine, I'll keep the candy, that's okay. So obviously the answer is on the slide, right? The whole point of spanning tree is we want to break the loop. So this is what we want to do. We're going to have some redundancy, some physical redundancy in our switched infrastructure. Obviously we want that at layer 1. We want some extra cables, that's clear. The problem is as soon as we introduce this, and who invented spanning tree? Where's my candy? What's her name? What's her? No, you got a candy. What was her name? What is her name actually? Radia Perlman. What year? What year are we talking about? Spanning tree, Radia Perlman. 84. 84. Quiet, Scott. Quiet. So, right? She came. She discovered a problem. If you create a layer 2 loop, she discovered that frames will travel and travel and travel. It leads to all kinds of issues, broadcast storms, duplicate frames, all this kind of stuff. So she came up with a very elegant, very simple solution. She called it spanning tree. And at the end of the day, what we want to do is that. That's all. But I don't want to disconnect the cable, right? I don't want to break the loop at layer 1. I want to break the loop at layer 2. And that's what she does. She came up with this protocol to actually do this. Let's keep going with the candy. You notice we're just doing a bit of review here, right? So what's the first step in spanning tree? What does spanning tree do out of the gate? Find the root bridge. Thank you. So step number 1, the switches are going to talk to each other. We'll see how they do that in a sec. we're going to elect the boss, the heart, the root bridge. We're going to elect the switch where all the traffic is going to flow through, right? That's where everything's going to happen. We're going to call that the root bridge. We'll see that that happens pretty quickly and pretty easily. So that's step number one. Step number two. Thank you. Step number two, we're going to elect root ports. So what's a root port? Okay, I'll ask you. What's a root port? Whoa, way back here. Yes, very good. So the root port is all about the other switches, right? So in step one, we decided this was going to be the boss up here. The other switches need to figure out what's the fastest way back to that device, the best way. We're going to identify a port that's going to do that, and we're going to call that the root port, right? It's the port leading back to the root bridge. That's why it's called the root port. So here's a good CCNA exam question. Are there any root ports on the root bridge? No, that's a very confident no, but he got a candy already. So who can give me a confident no? No, thank you, no. There we go. Only one candy. I only have a kilo of the stuff. All right, step number three. And this is the last step. Step number three? Yeah, thank you. So we're going to elect designated ports. And the designated ports, they're the ones that actually are going to stay on. And they're going to forward traffic. They're going to keep forwarding traffic. The lights are going to flash. It's going to be green on the switch. That's a happy port. All the other ones, something like this is going to happen. The LED is going to go kind of amber, orange, and it's going to physically be on, but no more data is going to go out of that port, right? We're trying to block that loop. That makes sense for everybody? Is that what you guys kind of remember? Again, if this is new to you, hey, no worry. We've got some books to give away at the end. So how does this all happen? What's the magic? We need to talk about the BPDU. So once I elect the root bridge, every 2 seconds, it's like a heartbeat. These BPDUs are going to go out of the root bridge. They're going to carry quite a lot of information. But I'll be honest with you, with the time that we have this morning, I'm going to focus on those 4 fields in the BPDU. There's way more stuff, right? There's timers and version and all that. But let's just kind of focus on those 4. So those are the 4 fields we're going to use throughout the next 20 minutes to kind of break that loop, right? To determine where the root bridge is, where the root ports are, and then where the designated ports are. So we can see we've got one field called the root bridge ID. What is that? Well, that's just the ID of the boss. Like, hi, my name is Patrick, I'm the root bridge. So I would put Patrick there. Hi, I am Patrick, I am the root bridge, I am the boss. Here's another CCNA exam question. When we plug a bunch of switches together and we turn them all on, BPDUs start flooding the network, right? They start talking to each other. As switches start sending these BPDUs, what value do you think they're going to put in that first field? Right? We just turned on the network. They haven't had a chance to talk to each other yet. But they've been told, because spanning tree is on, but who turned off spanning tree? Don't turn it off. Right? Spanning tree is on by default. Don't turn it off. So if it's not, so if I go back to my topology with those 3 switches, if I turn these guys on, start flooding BPDUs, what are we going to put? What are the switches going to put in that first field? Come on. Yes? Thank you. Their own ID, right? Because I don't know you, right? So I need to put something in that field. Can you guys pass the candy? Don't eat the candy. Pass the candy. The next field is going to be a value that we're going to call the root path cost. That's the value that it costs that switch, if you like, to get back to the root bridge. I'll come back to that in a second. Sender bridge ID, that's my name again. So again, if I go back to what I was saying earlier, if we've just turned on all the switches, then hi, my name is Patrick, and hi, my name is Patrick, right? The values would be the same initially. And then as we start talking to each other and we decide that, I need someone's name here, Paul is actually the boss of the network, then we're going to put his name and his ID in that first field. But I'm going to keep sending maybe BPDUs, and I'll put mine in here. And then this one's pretty straightforward. That's the port out of which that BPDU is going to go out. So keep these 4 in mind. We're going to use those a lot in the next few slides. What is the bridge ID? Well, the original version that Radia came up with was pretty straightforward. She was like, you know what? We're going to come up with something pretty straightforward. We're going to do the MAC address. So the MAC address is part of the bridge ID. And then she realized there was a small problem with that. She was like, if we just use the MAC address, then how are we going to kind of control that, right? Which switch is actually going to become the boss? I don't want it just to be based on the MAC address. As the admin, I want to control that process. So we're going to add a value in here, 16-bit values, and call it the bridge priority. And obviously, Cisco comes along. We got per VLAN spanning tree. So we need to track VLAN information in that. So some strange things start happening with the bridge priority where the VLAN ID value gets added there as well. Is this all making sense as well for everyone? OK, cool. So that's what we're talking about so far. Now, last slide before we go right into the demo, which is not really a demo, it's just a bunch of slides. When she came up with this algorithm, this protocol, she had to make some decisions. How are we going to elect this root bridge? How are we going to elect the root ports? How are we going to elect the designated ports? And she decided to go with a really straightforward approach. The lowest value always wins. So just keep that in mind as we go through the next few slides. Every time I ask you to compare two values, it's always going to be the lowest value that's going to win. The lower, the better. So the lower bridge ID is going to win. The lower root path cost is going to win, right? So keep that in mind. We're going to use that consistently throughout the next few slides. And then one last little thing. When we talk about the root path cost, there's a little bit of math involved. She came up with some specific values for the different speeds of the interfaces on a switch. And these were the original kind of values that we came up with at the time. And for simplicity, to keep the math pretty straightforward here, because it's pretty early in the morning, we're going to use the short version of the STP cost. More recently, you can flick that to long and get much bigger values. But when we're just doing a little demo like that, these numbers start getting a little bit massive, and they're hard to track in your head. So we're going to stick with these. And again, to be honest, just kind of remember these ones. These are the ones I'm going to use in the next few slides. So 100 megabits per second has a cost of 19. That's the cost of that interface on that link. And a gig link is going to have a cost of 4. Ladies and gentlemen, that's the end of the review. Are we ready to go through the challenge? Yeah. Here's our network. I've got 5 switches, SW1 through 5. I've got different speeds. As you can see, I've got some gig ports. I've got some fast Ethernet ports. I've got some parallel links, so there's going to be some interesting stuff happening here. And you can notice that on my diagram, I've got the bridge priority values for each switch. I was very nice to you all this morning. Notice that it's 32,768 across the board. That's the default value. I didn't change it. That's just the default value. I just like to stick with that. And you can see what the MAC address values are across the board. I think we're ready. We've got 15 minutes left. I think we can do this. By the end of the next few slides, by the end of the session, I want to break any of the loops that I can find in this topology. OK? Ready to go? Ready to go. Remember, we went through the 3 steps a few minutes ago? So this is what we're talking about. Step 1, going to elect the root bridge. I'm going to give you a couple of seconds. I'm going to remind you what the process is. Have a look. We need the bridge ID. I need the lowest value for the bridge ID and the bridge priority. So what's going to be the root bridge? So raise your hand if you think it is SW1, SW2. Got one here. OK, SW3, SW4. I'll get out of the way. SW5. You all get a candy. No, not really. I'd run out of candy if I gave you all a candy. But yes, I agree. We all had 32,768 across the board. This one had the lowest MAC address. Now, just a quick tip. When you're looking at the MAC address, are you looking at it left to right or right to left? Who says left to right? Yeah, not right to left. So we're looking at it from left to right. And we can quickly see we got 0009. Across here, we got 000B, B, B, F. Definitely 9 is lower than the others. Congratulations, we're done with step number 1. We've decided, not we decided, but the switches have talked to each other, right? Obviously, I'm not showing you all of that initial flooding, but they've exchanged BPDUs, and very, very, very quickly, they determined that SW5 should be the boss. Got the lowest MAC address. Are we all OK with that? All right? OK. That's probably the easiest part of spanning tree, right? Of figuring out all these steps. That one there, it's pretty straightforward. It's a fairly simple value to figure out. we're ready for step number 2. So what happens in step number 2? Well, all of that BPDU flooding continues, but now it's a little bit more strategic, right? Because now we've determined that this switch over here is the boss. It's the heart of the network. So every 2 seconds, it's going to beat, and BPDUs are going to go out. Now, remember we were talking about the root path cost. So here's a tricky question. It's not really tricky. How much does it cost the root bridge to come back to itself? Nothing, right? So what happens here is every 2 seconds, it's going to start sending out a BPDU with the root path cost of 0. It is the center of this network, so it's going to advertise it out that way. It's going to say this is 0 to get to me at this point. Now, this is where all the math starts coming into play. So these BPDUs are going to start traveling across all these links. And listen, I could have put a lot more arrows, but I think you can start visualizing what happens here, right? The BPDUs are going to keep flooding throughout the entire network. But what I just wanted to point out, and where I'm leading to, is the idea that this value is going to travel, let's say, across a fast Ethernet link. And we know that that's a cost of 19. So that's going to come into this port, and it's going to go, OK, well, that was 0 plus 19. So the cost for this switch on that port to get to that root bridge is 19. And that's the very complex math this morning so far that we're looking at. So it's going to have a value here of 19, because there's fast Ethernet here. So 2 19s over here. We've got another 19 here. And like I said, I didn't want to overwhelm you with arrows, but just kind of visualize what's happening here. That's just that initial heartbeat, and that's going to kind of continue up throughout the entire network. So what ends up happening is all the ports across all the switches are going to start calculating their root path cost. So what's the cost of that port to get to the root bridge? And the math is pretty straightforward, guys. Check it out. Let's have a look at this one. Switch to this port. Well, it looks like a gig port, so that would be 4. And it would be going across, let's say, this way, plus 19. So 4 plus 19 is 23. Same thing up here. I got 4, right? Gig port, so 4. And then maybe across here will be 19, so another 23. This one's interesting, 27. What happened here? We've got 4 across here, maybe 4 down this way, and then 19 down. Does that make sense? So it's just a little bit of math, and it's like I guess the important point here is it's a cumulative value, right? As it's going through the network, it's going to keep adding those values to figure out how far it is from the root bridge. So obviously, this goes a bit bonkers, right? Loads of flooding that's happened here. And what I've done is I've just cleaned that up a little bit to get rid of all the big arrows, and just to kind of try to simplify and clean up the math a little bit. So what you're seeing at all of these red values is this port on that switch, if it wants to reach the root bridge, has a cost of 27 there. Does that make sense? This one over here, I know this sounds crazy, but let's say we kill this, then it's going to want to go maybe this way. So what's the cost coming all the way around? We got 4, because it's a gig port, 4 again, and then maybe 19 this way. Is that all right? OK, so again, let's clean it up a little bit. And again, we can ask ourselves this first question, because I know I went a bit on a tangent there, but the idea of this is we need to elect the root ports. We're in step number 2. I had to talk about the root path cost, because to determine the root ports, that's the first value that we're going to consult. That's the value that we're going to look at. So if we have a look, let's say switch 3. It's pretty obvious, but let's have a look at it. We can see that switch 3 has a bunch of different ways that it can take to get to the root bridge. You can go this way, you can go this way, right? You can go all over the place. So it's got a bunch of different values. Who wins? High or low? Low value, right? Always the lowest value wins, and that means that this guy becomes the root port. Let's go look at this one. Switch 4. Again, 3 ports. I need to look at all of them. This one has a total cost, looks like, of 23. This one has a total cost of 23. Again, simple math. It's 4, because that's a gig port, plus 19, so 23. And obviously, we've got a straight link here of 19. This is going to win root port. Am I impressing you with my PowerPoint skills so far this morning? I'm impressed with my own skills. OK. We've got 2 done so far. Are we done? No. We still have, right? Remember what I said. We're in step number 2. All the other switches need to find a root port to get back to the root bridge. So I'll let you ponder this one for a second or two. We've got a problem here. At the top, that switch has 2 ports. Both ports have the same root path cost total, 23 and 23. What happens? we can't have a tie. That's the first thing that Radia realized as well. She's like, hang on a second, we can't have a tie, so we need some steps for a tie break. And what are those steps? I've got them up here for you. So step number 1 for that tie break would be the lowest root bridge ID. The ports are agreed. Who is the root bridge? So that value is going to stay the same. Step number 2, the one with the lowest root path cost. Well, we just said it's 23 for both, so that doesn't help. Step number 3, though, is interesting. The lowest sender bridge ID. So I'm going to let you ponder that one for a second, prepare a candy. Which port do you think would get to be the root port here? Will it be gig 01 that's connected to switch 2, or gig 02 that's connected to switch 3? Yeah. Why? So what he's saying, and I'll repeat it, basically he's saying, well, in step number 3, we need to look at the sender bridge ID. What does that mean? That means it's remember the BPDU I showed you? That's the value of the bridge ID of the device that's sent to the BPDU, right? So we need to look, because don't forget, the BPDU is coming up here, and the BPDU is coming up here. So it's going to look at that value, and it's going to realize that that one has the lowest bridge ID. Again, why? It's not the priority, right? We got 32.768 across the board. That one has got a lower MAC address. We got 000B, FD13. Look at that. There's a 9 there. This is a C, right? That guy wins. And as soon as that is determined, guess what? We got a root port up here. We're done. We're done with that one. OK. This is where we really see how your spanning tree is doing today. What's going to happen over here? So switch 2 has parallel links going to the root bridge. We both agree that they're all of a cost of 19. So we have a tie break again. We need to use the tie break process. So step number 3, is step number 3 any help in this case? No, it's not, because the sender bridge ID will be the same coming out of these 2 ports, right? So it's the same switch. So step number 3 doesn't help. Step number 4 is a value that a network administrator can tweak to break the tie break and make their own decision. Now, the default value on the port priority is 128. Let's just leave it at that so that we can skip that step, OK? So let's say they both had that same default value. That means we get to step number 5, and this is the kicker. It's the sender port ID. Sender port ID, not the receiving port ID. So which one is going to be the root bridge? Is it going to be, raise your hand, FA0/1? Raise your hand, FA0/2. Oh, we've got some confusion in the ranks. Let's look down here. The sender, what is the sender port ID? Let's keep it simple. It's the port interface number, OK? This one's a 1. This one's a 2. And what does it say over here? So what's going to happen? And I would bet a lot of people get this wrong in a CCNA exam question. Maybe even CCNP exam question, right? You guys remember the old route switch T-shoot exams maybe from back in the day? Had a lot of spanning tree in the switch exam. Definitely people would get this one wrong because we tend to focus, right? Because we're focusing on the switch here, we're like, I need to figure it out here. Actually, no, you need to take a peek down here and have a look at these values instead. That makes sense for everyone? OK. Congratulations, we're done with step number 2. We're ready for step number 3. Now, what is a designated port? I mentioned earlier, this is the port that's going to stay kind of enabled, right? It's going to stay on. Data traffic is going to flow through this port. A simple rule of thumb is that there should be, and must be, not should be, there must be one designated port per segment. Now, when I say a segment, I'll keep it simple here. I mean each of these lines, basically, right? Each of these connections between those switches has to have a designated port. It has to. So let's start with the easy bit. Now, how do you select a designated port? Again, we've got our decision steps, if you like. It's step number 2. We're going to use the root path cost again. So again, what we're doing is the switches are talking to each other. They have a BPDU on each side, and they're trying to figure out which one is the best BPDU. Yeah, which one is the best port on that link that will stay enabled, will stay up, and will be the designated port. So let's let's look at it from the easiest device, from down here. Right? We've got 4 ports over here, right? 4 segments that are connected. The root path cost here is 0, right? Because that's the boss, that's the heart of the network. Over here it's 19, so guess what? I think this is going to win, right? 0 is less than 19, so this should become a designated port. I have a feeling this one also is going to become a designated port, and I think this one as well. It's all zeros. Remember, we talked about this at the beginning. It's sending out a value of 0 because it is itself the root bridge. So guess what? These are all designated ports. And I'll give you this as another tip of the day. You can assume with 100% certainty that all the ports on the root bridge for this particular VLAN, let's assume this is VLAN 1, they're all going to be designated, right? It's always going to have the lowest value. It has to have the lowest value. I don't want to be, because if it doesn't have the lowest value, what's going to end up happening is we're going to block something here. And I don't want to be blocking a port that's connected to the heart of the network, right? Okay, so that was that one. That was the easy one. Let's do a couple of the other easy ones, if you like. So if we have a look at this switch over here, and we have a look specifically at this link, you can see that at the other end of this link, it's a root port. Now, is a root port important for a switch? Yes. If a switch loses its root port because a cable is disconnected, it freaks out, right? It needs to find quickly a new root port. So am I going to close this? Am I going to block this port? Am I going to break the loop here? It doesn't make any sense at all. If we look at the math, though, the math will help, right? 19 is less than 23, so that means that this guy's got to be a designated port, no choice. But like I said, logically it makes sense because we've got a root port at the top. There's another spot where this also makes sense, which is over here. Oh, no, over here. Sorry, this link. So we can see, no, not that one. Yes, this one over here. No, not that one. Where am I looking at? Oh, it's this link. Sorry. Yes, where the math is easy to figure out. We've got a 19 over here. We've got a 23. So this one wins quickly, and this one is a designated port. Now, I did those ones because those ones were easy. The math was pretty straightforward. What we're going to realize is that we have a situation in a couple of places. Have a look at this link over here. And to be honest, again, we can do the segments in any order, right? I'm just kind of jumping here and there. I need to kind of do the whole thing. So I'm just jumping from one segment to the other. So over here, we've got a segment between these 2 switches. Have a look, 19, 19. So we've got a problem at step number 2. They have the same root path cost. So I need to go to step number 3. So who's going to win here? Which one is going to be the designated port on this segment? Is it going to be switch number 2 or switch 3? Or switch 4, sorry. Who says switch 2? Who says switch 4? Let's have a look. Yeah, switch 4. Why? It's got the lower MAC address again, right? It's always the lowest value in this case that's going to win. So that was a hard one. Not saying it was hard. It was just a little bit more complex because we had the same values, 19 and 19. Let's have a look at this segment here. We're almost done. Again, 19 and 19. Who's going to win? Who's going to become the designated port? Is it going to be switch 3? Raise your hand. Or is it going to be switch 4? Raise your hand. Let's have a look. Yeah, switch 4. Again, it's all about that step number 3 here. The one with the lowest MAC address is winning. Switch 2, switch 3. This link over here. Again, 19 and 19. Who's going to win? Who's the designated one? Switch 2, raise your hand. Switch 3, raise your hand. Nice. Yeah, switch 2 is the designated port. I think we're done. So what ends up happening is that once those designated ports are selected, now we're ready to actually break the loop. And what I mean by that is, and you can see I put these massive red X's, all those other interfaces on those switches are going to become alternate ports. You might see that if you do a show spanning tree, and they're going to go into blocking. Again, the light's still going to flash on the switch. BPDUs are going to be received, but it's going to be in a very passive mode, right? No data is going to go out of those ports. So we've basically blocked all of those ports on the network. And what's the end result? This is the end result. What I've highlighted in orange are the only links in that topology where data is actually able to flow. So if I plug in a PC down here and a server up here, which way is it going to go? It's probably going to go like this and like this, right? Not just probably. It's got to. This is blocked and this is blocked. So that's the only path available. If I put a PC up here and a server down here, well, that's going to take that path and come down this way. And so that's all that's left in terms of a working environment at the end of the spanning tree. And this happens very quickly. Obviously, I'm talking about classic kind of legacy spanning tree this morning. We've got rapid spanning tree now, right? It's going to do this very, very quickly. And also, more importantly, with rapid spanning tree, it's going to recover very quickly as well. That's the whole idea. Ladies and gentlemen, that was spanning tree in a nutshell. That good. I know that there's a WebEx room for this session, so I'm happy to drop a copy of the slide deck in the room if you want to join and you want to have a look at it on your own. So like I said at the beginning, I've got some books to give away. For mine, what we'll do is once everyone's gone, those of you that are planning on taking the Encore exam within the next month or 2 or 3, come to the front. We'll do a little draw just with you guys, because I'd like the book to go to someone who will actually use it. Scott, my fellow Canadian, who wrote the CCNA Portable Command Guide, he gave me a couple of copies. What we've done, and Emma, just correct me if I'm wrong, we've put little tickets under the seat. Could you have a look under your seat for a little ticket? Is it like far under the seat? No, it's like right at the front. Eh? Okay, so if you have a ticket, come to the front. It should say either Cisco U or what? Or CCNA. If it says CCNA, feel free to grab yourself a copy of the Portable Command Guide. If it says Cisco U, come and see Emma. She'll give you an access code for, yes, grab yourself a book. Thank you. And she'll give you an access code for access to Cisco U as a, no, sorry, no, it's a Cisco U giveaway. I'm so sorry. Pickleball set. Yeah, we got a pickleball set. So did everyone find a ticket? Got a ticket? CCNA can grab a book. Anyone find a ticket that said Cisco U on it? Yes, go see Emma for that. Right, thank you everyone for joining. Much appreciate that you were here. Again, those of you that are taking Encore soon, let's come to the front and we'll do a little draw for that one.
Good morning, everyone. How you guys doing today? It is Tuesday, but it feels like it's Friday already. Hopefully your week is going well. I'm Kareem Iskander. I lead technical advocacy here at Learning and Certification. My team is responsible of advocating for everything that we do here with learning and certification, from certification as well as the technologies. One of my favorite topics to talk about is Meraki. I've been at Cisco for 16 years, and I've been with DevNet for a while. I was one of the advocates there that started DevNet, and so I helped shape the Meraki APIs with the Meraki BE, and so I like to do these sessions as I build code for our customers, and I like to share it on Cisco Live, so at Cisco Live. So I wanted to put this session together to show you how useful it is to use Meraki Action Batch, especially when it comes to your automation. But just a show of hands here, who's familiar with the Meraki APIs? Okay, so that's okay. We will talk about the APIs, and then this is going to go against my rules, but I'm actually going to do a live demo, and so 50-50 chance it might work. It worked this morning, but it never works on stage. You know, demo gods, and as you know. So we'll see how that rolls. Little housekeeping, there should be a room created for this session, and if you have any questions, I'm happy to answer afterwards. And if you don't have a room created for you, feel free to just reach out to me directly. I'm happy to answer any of your questions. But so what are we going to do here? I'm I'm going to give you a quick introduction of the Meraki APIs and what we're trying to do. I like to tailor my sessions around a real-world use case to give you an idea why are we doing this and how useful it is. So we're going to talk about that use case. And then we're going to dig into the Meraki APIs. I'm going to show you how, if you were to implement this using just the organic Meraki APIs without Action Batch, how the differences between the two and how useful it is to batchify your use case. And then we're going to go, I have the code ready. We're going to go through the code. Everything that I am talking to you about today is available as a tutorial on Cisco U, my code, the explanation, the step-by-step on how to implement it on your own. If you head over to u.cisco.com and search for Meraki Action Batch, it will show up for you, and it's free. Just log in with your Cisco account. OK. So here's the use case that we're going to be working around. You're an organization, and you're rapidly expanding your operations to multiple locations worldwide. You have multi-sites have been defined, and you are looking to deploy throughout these sites over 1,000 Meraki devices. You're the network automation engineer. You've been given the device serial numbers, and you're given where the network architecture of it, and you're tasked with going to deploy thousands of devices throughout 6 or 7 different sites. Now, if we look at that use case, we got to understand how the Meraki dashboard itself works, so we can drill into the APIs and figure out how to implement that use case and automate it. So for those who don't really know how the APIs or Meraki works, you are given an account. You are an account admin. Within that account, you can manage multiple organizations. Organizations have networks, and there are different types of networks in the Meraki dashboard. In Meraki itself, you have combination network, which is your MR, MX, MS, your switches, your access points, your firewalls, your sensors, right? That's a combined network. You could also deploy just simple networks. If you're just deploying a bunch of APs and that's it, you can do an MR network. So organization has networks. Within the networks, you have devices, and that's how you manage the devices, and then devices contain configuration, right? And so the reason why we talk about this is because as you're implementing your use case, you got to understand that first, I got to understand the organization, get the organization ID. Then from the organization ID, I need to get the list of networks that belongs to that organization so I can iterate through them and then apply and claim these devices in the different networks. Followed by, now that I have the devices attached to different networks, I can configure them, right? And so this kind of gives you an overview of what we're going to do. Now, if we were to look at this from an API perspective, keeping in mind that this is for one device only, right? In order to claim it into and create a network and claim it into a network and then configuring it, these are kind of the different endpoints that we have to figure out. First of all, you're going to have to go authenticate, and this is typically given a token, a bearer token for your organization ID. You have access to that from your dashboard. Then you got to go and call the /organization endpoint, and you do a post request to create the organization. Within the organization, you got to actually claim these devices in the inventory and make them part of that inventory. And then with the organization being there and you having access to it, you can, the next API call that you got to do is organization ID, capture that, and create your networks. And you have some mandatory fields that you got to post as part of your body for that API call. You got to then say, I have the entire inventory in my org. I'm going to take the first, 10 MRs, move them to this organization. We're creating multi-sites, right? So you got to be able to say, this list of devices belong to this network. These list of different devices belong to that network. And then once you've assigned these networks, these devices to the network, you're going to have to call multiple endpoints to essentially configure them, right? Whether you're configuring SSIDs, or maybe you have the management VLAN, maybe you're just configuring the naming of your switches and their location, just simple metadata tagging right to those. So if we look at this, sure, we can implement all of that using the organic APIs and the dashboard API. It's no problem. But if this is for one device, if you think about it over 1,000, you're going to have to do a lot of API calls. And if you're doing Python, right, and you're just using request library or something, you're going to have to manage all the errors yourself. You're going to have to do the error handling. You're going to have to make sure that the right APIs are called in the right order. And so you got to handle the timing of these API calls, as well as rate limits, right? Because now we're talking about one device multiplying that by 1,000. You got to handle that rate limit on your own. And this is where Action Batch comes in play. So we look at our use case that we talked about. So imagine you had to deploy 10,000 security appliances, 50K access point, 50,000 cameras, and maybe 15K switches, right? This is an actual use case that we worked with Starbucks on, and so this was something that was real. And so we're looking at 125K devices in total, over 6 organizations perhaps, and maybe 12 network admins. If my math is correct, right, we're estimating 10 API calls. We're looking at making, at 125K devices, we're looking at making 1.25 million API calls on your automation and deployment. So there must be a better way than having to call every single endpoint for your API. And this is where Action Batch comes in. So what is Action Batch and what's the benefit? It's basically allowing you to batchify all of your resources and endpoints into one API call. And so from a dashboard API perspective, there is no rate limit because you're calling one API endpoint, and this is creating an Action Batch. And so it allows you to deploy multiple changes across networks and devices. Batches can run synchronously and asynchronously, which is great because if we go back to our use case, we got to make sure that our organization has the right networks first before we can apply the devices to the different networks. So they have to go in order. So it's important if you're going to make an Action Batch call for this to be synchronous. Meanwhile, if you're going to deploy the thousands of devices, configure the thousands of devices, you don't care if the SSID is created first, or your management VLAN is configured, or your MX appliance has the right connectivity. It doesn't matter. It could go do it in whatever order, right? And so it's important to understand that you can call synchronously and asynchronously, and there are some differences that we'll cover. And then Action Batches are all or nothing, which is really important. Which means what? I'm going to go claim thousands of devices. Maybe one of those devices have already been claimed in a different organization. If it was not all or nothing, it would have claimed the 999 and then failed. And then you had to go back and remove these devices from the inventory manually in order for your script to run. Meanwhile, the Action Batch, what it does is, once it completes and it successfully completes it, it's going to essentially apply the configuration changes. If it fails at any point, it's going to go back and come back with an error saying it was incomplete and no changes to your organization will take place. Okay? Now, if we dig in a little bit on Action Batch details, so Action Batches allow an API client to define a batch of right actions. So you have different actions, all of which are documented as part of the endpoint documentation on developer.cisco.com or developer.meraki.com. And so you have different actions. You have create, update, and destroy, which is very similar to if you were to take one endpoint and you were to do post, get, put, right? And so you have different write actions. These are not limited. If you look at the documentation, the majority is create, update, destroy, but there are some unique ones, especially like if we're claiming a device, the action would be claim, it would not be creating. So you gotta just pay attention to the action and what it is in the documentation. Like we said, batches are atomic, which means it's all or nothing, and this is why we discussed why it's useful. Now, I want you to pay attention to this while you're building with batches. If you were to define your batch as synchronous, it could only handle 20 resources. And by resources, I mean the changes that you're planning on doing to your network, right? A resource could be configuring an SSID. A resource could be claiming a device. So if you're doing them in order and you need them to be in order, you can only have 20. But if you don't care about the order and you're saying they're asynchronous, you can go up to 100 resources. And then you can do up to 5 concurrent batches at a time. Which means in one API call, you could do, if it's asynchronous, you could do up to 500 changes, updates to your organization, which is really, really powerful if you think about it when it comes to automation. So, and you can have, so this is also important, you can have different types of resources, obviously, if it makes sense, right? So you could say, I'm going to claim devices in the same resources as after I claim them, I'm going to configure them as well as add admins to them. All of these could be in one API call as different resources. And a live demo will see how that goes, okay? So if you, this is from the documentation. In order for you to properly create an action batch, these are the pieces that you need. Recently, Meraki has changed the way they authenticate, so it's no longer the Cisco Meraki API token. It's authorization followed by bearer and token, right? So they still accept this, but it has changed, I think, about 6 months ago. I have not updated my screenshot. I will. A couple of pieces for you to understand. Confirmed, true or false. If you set confirmed to false, it allows you to basically mimic what's going to actually happen to your network before it happens. So it's going to simulate the changes, and it's going to come back and say, this action batch ran successfully, and here are all the changes that would have been applied. Until you set it to true, it will not apply any changes. Synchronously and asynchronously, this is the part that we talked about, right? If you set synchronous to true, it's gonna go in order, right? And you're only limited to 10. If you set it to false, you have up to, 20. If you set it to false, you have up to 100, and that would run it asynchronously. And then the action itself, right? Part of the action body, you need to give it the resource of what you're gonna do. So different resource URI have different actions have different resource or URI, and you would typically get that from the documentation itself based on your intention of what you're trying to do. And then the operation. Each resource has different operations. Some resources have limited operations, but the majority of resources have your create, update, and delete, which means you can actually stand up an entire network in one action batch just to see what's going to happen when you deploy it, and then you can destroy it by changing the operation from create to delete. Okay? And then the body, think of it as what is it that you're posting to that API endpoint for it to take action, right? If you think about, forget action batches, but if you think about it from a standard, just a simple API call, and when we do a post to any endpoint, you have that body in the request that says, maybe the name of the switch, the location of the switch, that switch ID, or maybe the IP addresses that you assign to it, right? So all of that is part of the action batch itself. So if we go back to that use case that we talked about, now, if you remember from the first slide that we did, it was about 10 different API endpoints that you had to manage. That same use case for what we were talking about, we can do it in 3 batches. Your first batch is to create the networks. So you already have the organization. You're going to have a batch that allows you to create the different types of networks. The second batch, and this is going to be synchronous. I wanted it to be synchronous because I wanted to see the different networks to be built from 1 to 6, and I'll show you that. The claiming of devices could have been asynchronous or synchronous. I said to have it be synchronous, and this is basically saying I have a list of devices that are mapped to the networks that we've created. We're going to extrapolate the device serials, and then we're going to go through and batchify that to create, to claim them into the network. And then once they are assigned to a network, I can create an asynchronous action batch that says what I have about, in the example we're going to be using, I think I have about 30 devices. In our case, we're going to go, when the device is access point, we're going to configure the SSID. When the device is a security appliance, we're going to configure the management interface on it, and then we're going to configure the VLANs on it. Okay? So let's look at the code. Does this make sense? All right, so if I look at this, I have an empty organization here. This organization, we're going to do that use case where we're going to create multiple sites. There's nothing in this that hasn't been configured. If I look at I have my design document here that says I'm creating 7 sites. Can you guys see this in the back, right? Yeah. I'm creating 7 sites. Each site, this is the location of it. I'm going to use the location as the name. I have the IPs for the MX, IPs for the MS, and IPs for the MR, as well as the device serials all sitting there. Then I'm going to bring that into my script, loop through it, and then make the decisions and create my action batches on the fly. And so if I look at my code here real quick, so we're going to be doing a couple of things. This looks OK for you guys in the back? OK. So if I look at my code, I have my API key here. First thing, I need to basically get the organization. So I need to extrapolate my org ID. And I'm looking for, because I'm managing, as part of my token, I'm managing over 10 different organizations, right? I only care for the Cisco U Meraki org, that this is where I'm going to create my networks under. So I'm filtering on that. I'm capturing the org ID. And then I'm saving it. And I'm saying, OK, now that I have the org ID, I can go in and create my action batch, my first action batch to create the networks. And so you could see the building blocks to that action batch that we've defined. First, we got to give it a name. This is a mandatory field. And I'm basically saying the name of the action batch, which is creating the network name itself is going to come from our inventory CSV file that I showed you, and it's going to be the location. So my network is going to have the name of the location where it's defined in my Excel sheet. I'm creating a product type. I'm creating, basically saying this is a combined network. So I'm supplying these values in. I'm giving some random tags in there just to show you that I could do tagging. And then I'm setting the time zone as well as adding a note to this. This is part of the action batch to create the network itself. And then finally, I'm saying, what is it, the action that I'm actually going to be doing? In this case, the resource, I know I got it from the documentation, is organization, supply the org ID, and I'm creating networks. That's the networks endpoint that I'm doing. And then I'm going to go in and say, OK, now that I have this, I'm going to take the body of the action, and what I'm doing is basically I'm iterating through all of that, and I'm supplying it to this organization ID and actions, and I'm saying it's confirmed true, which means go create it, and then I'm synchronous is true, which are the flags that I have talked to you about. Does this make sense so far? OK, one thing that I want you to notice here, too, is Meraki made it so simple for me that I'm actually using the Meraki dashboard API SDK to build my script. So I didn't have to handle all the API requests, even for the simple creating those action batches. So the SDK is actually a really powerful tool that you should leverage while building that automation. You don't have to handle errors. It just comes out of the box with a lot of things. So, okay. So now that I have this, the next batch is, after I created my network, is actually claiming the devices into that network. And so I'm going in and simply saying, I'm going to read the devices, I'm going to extrapolate the device serials, and I'm making this is not a batch, this is just a simple API, one API call that says I'm going to claim I'm going to put in my devices in my inventory in my network, essentially, before I start assigning them to the different networks. And then now that I have the networks and I have the devices in my inventory, I can say, cool, now I'm going to create another batch that's going to take all the devices. It's going to check if these devices belong to that network, to assign them to that network based on the name of the network from my CSV file. And it's going to dynamically build my action batch for me here. And I'll show you guys, once we run this, I'll show you what the batch itself looks like, so you would have an idea. And then finally, once I've assigned these device serials to the networks using this resource right here, I'm going to go in and essentially configure it. And I'm doing a bunch of configuration. I'm configuring wireless SSID on all my on my different networks, and I'm giving it a Cisco U Wi-Fi access SSID. I'm also configuring my management interface here. And I'm doing a bit of logic. Since I have the IP addresses in my CSV file, I'm saying that to replace the last octet with .0, so that would be my gateway. And then I'm going and saying create my VLANs. I'm creating my management VLAN. And I'm doing all of that in one batch. And it is going to be, in this case, asynchronous, because I don't care for it. And plus, it's going to be more than 20 configurations, more than 20 resources. It doesn't need to follow an order. And I think there's going to be about 60 configurations that we're going to be doing here. OK, so if this runs, we can still talk. If this does not run, you guys could leave. So let's go ahead and run this. And it's going to take a couple of seconds here for us to see it. So I'm going to run that deployment. And it's going to go through in order. So it's going in and creating my organization batch. Sorry, creating my network batch. And this is the first one. I got my organization. I got 200 OK. It created my networks. So I'm going through, and it should give me 6,201 created. I'm getting the organization and ID now, and I'm going and posting and creating the networks before I claim the devices in there. Come on. There we go. And then finally, I'm configuring devices with one batch, and that's the last one. So it succeeded. Before I show you what the organization looks like now, if we look at, I outputted some of the action batches, the 3 action batches that we've done. So creating the network, this is one batch right here that I'd like to show you. So you can see that I've created one batch, confirm, synchronous, and the action. And look at the action. The action has multiple resources, one for every single network. So there is San Diego, there is Boston, and there is Fairbanks. So you could see that this is one API call. The body of it is one batch. And you can see the multiple resources here. So we created that first. The second part was to claim the devices into the network. So we got the different network IDs here as resources, and then this is how we dynamically built the serial from that CSV file. We brought it in, and it created that entire batch for us to do one API call to claim everything in the different networks. And then finally, configuring of the devices, and this is where we said it's going to be asynchronous. So you could see all of the configuration that got applied to the different devices here. And this was definitely more than 20. Okay, so that was what we posted to the action batch endpoint. And now if we go back to our Meraki dashboard here, you could see that now I have the 7 different locations that I deployed with the tags. If I were to go into one of my networks, you can see in the inventory that I've claimed all of the devices that were defined in that sheet for us, and I've assigned them to the different networks. Here are all my serials that belong to different networks, right? And then if I were to go at the switch level, you could see that I've configured the switch name after I've claimed it and added to the network, which was another action batch as part of my configuration. The network here is a little bit slow, so. Here we go. So I have the switch device. I called it SW device, as well as it has the location itself, as well as the configuration and IP management. And I mean, all of it, the MX was configured, the SSID is there, so it's all configured. Since this is taking forever, I'd hate for you to, so here, the location was moved, the marker was moved to San Diego based on the address that we got from the CSV, and you can see if I click on IP address, it gave it the 10.0.1.2 from our configuration file. It gave it the net mask as well as the gateway, which was all defined for me here in this file, right? And so my wireless access point is also the same. My SSID is there. So you can see how easy it is to use the action batch to configure. We have our Cisco U Wi-Fi there. If I look at my appliance, my security appliance, my addresses and VLANs, this should have the management VLAN configured here somewhere. So you get the point, but what we've done is we were able to deploy all of this in less than 30 seconds using 3 API calls. So you can see how powerful these action batches are. But what I'd like to leave you with is everything, including the code and some test devices, is available for you on Cisco U. Check out that tutorial, and if you have any questions, let's discuss it. But hopefully this session was good, it was informative, and you liked it. Thank you for joining me this morning, and have a nice rest of your week. Thank you.
Perfect. We'll go ahead and get started. Sweet. All right, audio's ready. So for those who couldn't hear me in the back, thank you so much for showing up this session. I started this session last year at Cisco Live Melbourne as kind of, I almost submitted it as a joke. And the fact that I still draw people and that people want to show up and learn, I'm a Vim user on a daily basis, so the fact that there's so many people that actually sit here and want to learn more about it brings a lot of joy to my heart. So I appreciate you sitting through this. I know it's lunchtime. I know we're all ready for naps because conference season is crazy, but you will not regret sitting here for 30 minutes and listening to me drone on. So with that, my name is Quinn Snyder. I'm a technical advocate with Cisco Learning and Certifications, and this is an introductory session on how to use Vim. Now, a lot of the stuff, there's a lot of different versions out there. There's original VI, there's VI improved, which is Vim, there's NeoVim. A lot of this stuff will translate pretty closely. If you're using original VI, some of the stuff may not be 100%. But the best part about this is not only will I be giving you a presentation about it, I will be driving on the command line and I will be popping up my keyboard so you can see that I'm not lying. There's nothing going on between my fingers and the keys except for typing into VI. So, we'll get started here. I believe a session was, or a WebEx space was over this. You guys have seen this slide a lot. If you want to ask me more questions and follow up about what I use, I'm a daily VI driver, like I said, or if there's any follow-up questions you have, ping me in the WebEx space for this session, and I will be more than happy to answer. The June 7th date is completely wrong. I will moderate it probably in perpetuity. I keep doing that. So, we'll start off with why do we use Vim at all? And we'll talk about some standard defaults that I like to use to make it a little bit more palatable. There's a ton of different configuration options that you can put inside of VI. These are just some bare bones defaults that make it usable for those who are coming from more of a UI-based text editor. We'll talk about navigation, how to search, how to replace. We'll talk about VI's mode, or Vim's mode of operations, how to insert, what visual mode is, what all those things mean, because they can be kind of intimidating if you're not familiar with them. If we have time, we'll talk about cut, copy, and paste, because Vim does things a little bit differently. And then finally, I'll bring up a conclusion where we'll have a quick cheat sheet that if you want to copy. I will also be dropping a PDF version of these slides inside of the room as well. So if you want to join that space, I'll drop this slide so you have the full reference as well. I also have, again, these started off as jokes and they became very popular, an introduction to Vim as well as an intermediate Vim tutorial on ciscou. So if you create a free account with ciscou, they are our tutorial platform. So they're always free. You don't need anything beyond just signing up. Those two tutorials will get you started with using VI. I cover a lot more, especially in the intermediate one. We talk about buffers, tabs, how to fire open terminals inside of a VI window. So you can really use it as your daily editor, just like you would use VS Code almost, or PyCharm, or pick your editor of choice. So I'll leave that up for just a couple of seconds for those who have their cameras up. And we're good. Okay. Okay, so why Vim? It is literally everywhere. So if you run any Linux-based operating system, any Mac OS, even Windows subsystem for Linux or WSL, it is part of the base install for nearly everything written in the past, or developed in the past, I don't know, 15, 20-ish years. This also includes, like I said, for those who are using Windows, there is an application called GVim, or Graphical Vim, that you can install. I prefer the WSL version because it's full text-based, and because it's a full OS, you will get the full VI. You'll get full VI when you install a WSL installation. It is actually simple enough to learn for basic editing. I know you're in disbelief, but it is simple enough to do some quick editing when you need to jump in and SSH into something and provide some edits. A lot of people are saying, I'm a Nano person or I'm a Pico person. That's fine. I don't edit or hate unless you like Emacs. Then we'll throw hands. But the problem with Nano or Pico is they're not installed as part of the base OS. You have to do some kind of installation with apt or DNF or whatever you're using for your package manager. And sometimes I've worked in secure enclaves, both in the federal government space as well as in other areas where we can't install outside packages that we don't have full control over. So sometimes VI is all you've got. Another point that people often bring up to me is, well, we have VS Code, we have PyCharm, they have remote development plugins. VS Code, you click the two little arrows and you can connect via SSH and connect to the system and you get the full tree view and everything. That's fine, and I use that in all of my labs as well for people so they're not focusing on VI, but they're focusing on the lab. But they oftentimes require some kind of server-side download. They're not coming from your local system, it's pulling it directly from like the Microsoft or PyCharm websites to install that. So if, again, secure enclave, not trusting the software, you may not even be able to install those plugins to do remote SSH. The last 2 points are kind of, well, the last point is, or this next point is really kind of why I like it. Your fingers get to stay on the keyboard. I don't need to use a mouse and click and move and do all that. My fingers can stay, I can navigate, I can move back and forth, and you can amaze your friends with tricks you learn in the shell. I actually have VI running as my editor of choice in my shell, so instead of using like Control-A, Control-E, I have Vim bindings inside of my terminal as well. And the final piece, if you do nothing else with VI, if you want to add a new user to the sudo command inside of your Linux subsystem, you have to use VI sudo. You have to. If you edit it outside of that, it will break because the chain of trust is not established. So you must use VI for that purpose, if nothing else. So let's get started. These are the defaults that I like to use. So by default, VI is meant for a light editor window in terms of syntax highlighting. So I will generally turn on and enable a dark background, which brings a lighter text up to the window by default. That you won't see that in the screen that I'm using now because I'm not doing any code editing, but for like if you're editing Python or Go code or some kind of bash commands, that syntax highlighting and changing that to background equals dark will be very beneficial for you. If you like dark terminals. If you like light terminals, you don't have to worry about it. I do question your sanity though, because it burns my eyes. The next two commands, set number and relative number, I'll go through those, but when you fire up VI, you don't have line numbers on the side. So we've got to debug things, and we've got to figure out where things are at. If you do set number, that will give you line numbers on the side. If you do set relative number, that will show you how many lines up and down from your current line those lines are. So if I'm in, say, line 5, the lines up will go 1, 2, 3, 4, and then 1, 2, 3, 4 down from there. So it's relative to your cursor position, and I'll show that as well. How many folks have dealt with things that are very white space specific, and by that I mean YAML? You've written some YAML stuff. You have to line up things, number of tabs or spaces. We won't get into that debate. But there's things that you can install in like PyCharm and VS Code, like indent rainbow or vertical ruler, things like that. Vim's had that built in for a long time. You set cursor column, which means it will have a column above and below where your cursor is, and as you move left and right, that column will move so you're exactly indented. VS Code is solving a problem that's already been solved. And then finally, set HL search, which will highlight our search results into the current buffer. So normally when you search, it does not highlight the words that you're searching for when it finds them. Set HL search will do that for you automatically. If you store these in, or if you activate these from the terminal window, you will need colon. That's the command mode, colon set. You can place all of these commands inside of .vimrc, your home folder .vimrc, and if you remove the colon, so you would just do set bg equals dark or set net number relative number, every time you instantiate Vim, those defaults will be there for you automatically. So I'm going to do them from the command line. I don't have them set in my vimrc. But if you want to put them in vimrc, just remove the colons and you'll be fine. So with that, I have some text here. So let's get in here. You can see my cursor is highlighted over the exclamation point. I'm going to type shift colon, or shift and get the colon. And I'm going to do set bg equals dark. Didn't change anything here because again, this is plain text. It's fine. Like I said, if you're doing code and syntax highlighting, it will change there. Let's do set relative number because I think that this is the thing that folks have a little bit hard time grasping. So you can see over here on the side, I'm down in the last line, which is line 11, is indicated here, but you see a 0 next to my high. Those lines up are relative, so they're 1 through 10 lines up from where my current cursor position is. Now, Quinn, why would you need to know that? We'll get to that point. But we can combine those two, and you can see that it's going to move as I move up and down. So you can see that 0 is moving up and down as I move my cursor. Handy if I want to jump or need to skip lines. But you say, I still want to know what current line I'm on because I need that information. So this is where you can combine the two, set number and set relative number. So if I do set number, you can see that my 8 has moved over to the side. That's my current line number. We can assume that to be 0, so as that moves, you'll see I'm on line 5, 4, which lines up with the number down here, but the numbers are relative to my current position. So I get the best of both worlds. I know I'm on line 4, and I know how many lines up or down I need to move if I'm going to skip up or down in my lines. Cool? Let's set HL search. We'll get to that later. That's foreshadowing for things to come. And let's set cursor column. This is the handy, if you use nothing else, this will simplify your life. As I move over, that column will follow me. That way I know if I'm indenting things, if I'm running Python, if I'm running YAML, I know exactly where things line up for the indenting. So I can use it very quickly to say, is this indented or not? Sweet. So we have our default set, and I'm going to minimize that. Okay. Basic navigation. One of the common complaints that people have told me is that navigating in VI is hard. We got to move, you've got the H, J, K, and L keys, and that moves up, down, left, and right. Arrow keys are okay. You don't need to worry about those. You can use arrow keys. They are mapped fine in Vim. VI, you'll have to map them yourself, but in Vim, by default, you can use arrow keys. The next piece here is numbers augment the amount of movement. So if I was to say 5 arrow up, it's going to move my current cursor up 5 lines. If I say 7 left arrow or right arrow, it's going to move my cursor 7 characters to the right. So we talked about why do we have the relative number in there. So now I can say, I'm on this line, I need to move 3 lines down, 3 down, and I've skipped those lines. So now I've created a really quick way to move back and forth in front of my files. Some other stupid human tricks that I like, 0 and $sign move to the front and end of the line. So 0 will move you to the front of the line, $sign will move you to the end. You can move by words. So B and W, so backwards moves you, or sorry, B moves you back, W moves you forward. If you capitalize those, it moves beyond the white space. I'll show you what I mean by that. Most commands in Vim have a lowercase and uppercase equivalent. The lowercase will do one way, the uppercase will do the same thing but slightly different, so you can explore those things. So if you know one, you can know both of them. The bullet here by itself, :num. How many folks have used a Linux-based system, maybe you've got a lab or something, that you SSH from a jump box into, say, switches or other Linux hosts, and you SSH, say, 10.10.2050, and you get that error back that says, wait, the SSH keys don't match. You've got to clear them out from known hosts. Everyone's got that? And it says, hey, it's on line 255 of .sh known hosts. And so you sit there and you go, you hold the arrow key down 255 times to get to that line. You don't have to do that. :number will jump you right to that line. So when it spits back that the duplicate entries on line 128, :128, double D to delete the line, and you're back in business. That in and of itself is worthwhile. So cursor, column, and number, you guys are going to be experts at this point. Finally, :W is, and I like this one. People will argue, say that means it saves. I like :W to mean write because of write erase. That's just how I remember it. So :W writes, :Q quits, :WQ writes to the file and quits. So you can combine those two. All right, so talk about movement. So down here in the corner, we see that we're at line 5, position 12. If I want to move, say, 4 lines down, I can fire up my keyboard first, so I'm not lying. We hit 4, and then the arrow key down. I'm now on line 9. 5 plus 4 equals 9. So I've skipped really quickly. I want to move position 12, say I want to move back 5 positions, I'll be at position 7. So I can do 5 there, and I've moved back to position 7. So you can use the arrow keys, but you can augment those directional movements with numbers. What was the next one? That was the, I'll show the 0 and $sign. So we're on position 7. 0 moves you to the beginning, position 1. $sign will move you to the end, which is position 37, which is back here at the end of that line. Now, what you'll have to remember about VI is that the lines are entities in and of themselves. If I try to arrow over, you see I'm hitting the right arrow. It's not moving over to the next line. So each line operates independently. So I can't just arrow over and have it return back and scoot over. So you have to make sure that could, just a handy trick to hold on to there. All right, let's talk about word movement. All right, so I'm up here. Let's be on the vary. I'm going to move by a word. I'm going to move forward. I'm going to hit W. it moves me to the next word. Moves me to the next line there. If I hit B, it moves me back. Now, I'm hitting B and W, and I'll show you this. You see how B and W are stopping on the comma? It's treating special characters as their own words, which can be handy if we're dealing with writing code. We've got parentheses, we've got colons, we've got curly braces. Each one of those will be treated as a word. So we can make sure that we catch those. We're not skipping over them because they're part of our overall document. But there may be times where we want to say, we're going to ignore those special characters, move by white space blocks. In that case, I'll do Shift and W, and it skips over those special characters. So it's basically, do we treat the special character as a word or not with B or W? And I'll show you that here. We can go B, W. We're just moving across that column. Let's see, what else was on there? Okay. And then the last piece here. So like I said with the SSH, so let's see, this would be line 9. So if I want to jump from here to line 9, I do colon 9, enter, and I jump. Importantly, I jump to the beginning of line 9. Even though my cursor was over, the colon line number will move you to the beginning of that line that you declare. So that's where those SSH keys come in handy. All right. Feeling good so far? Like this is all easy enough to learn? Like you can take this back and use VI tomorrow? Okay. The other thing that really confuses people is the modes of operation within VI, or Vim. By default, when I open VI, I'm in command or normal mode. Means that I'm just navigating, moving stuff around. If I type letters on my keyboard, it's going to perform the function that's mapped to those keys. It's not going to enter any text. I need to insert the text into the document. You do that by hitting I. And it will change and show insert at the bottom, and I'll show that in a second. There's a couple of different ways that you can enter insert mode. I is the most common and easy to remember. Append, which will move your character to the next space, and then you type. And then change, which will change based on what you want to put, whether you change a word, change a line, whatever. You can hit C, and that will also bring you into insert mode. Then we have visual mode. And this is what we use for text selection and manipulation. So from normal mode, let me take a step back. If we're in insert mode and we want to get out, hit escape, takes you back to normal. From there, once we're back in normal mode, we can enter visual mode if we choose. V, little lowercase v, will place you into visual mode. Creates a line, you can highlight any free-form text you want there based on the characters. You can move over character by character. Capital V will place you into visual line mode. I'm highlighting lines at a time. So if I wanted to take a chunk of text and move it up or down in my document, I would use Shift V, highlight the 3 lines or whatever I want to move, cut them, and paste them up to the top. And again, escape will return you back to normal. So I'll show you that just here in practice. I have, I want to add a new line here, so let's go down here to the line 10. I'm going to hit I. You can see the insert pops up down there in the corner. That means I'm in insert mode. I can add text. This is in insert mode. If I hit escape, that took a second. You see the insert goes away. I'm back to command mode, and I can do my normal navigation as I did before. But say I want to highlight something based on characters. I type V, see visual, and I can use my arrow keys. Sorry, I forgot to pop up my keyboard. I can use my arrow keys, and it highlights character by character. Again, you can highlight that. You can cut and copy and paste, which we'll get to. If I hit escape, it goes away. Nothing, no harm, no foul. And I'll show the line visual. We'll do Shift V. Not emojis. Not emojis. Although updated versions of Vim do render emojis 100% correctly. Again, VS Code just solved a problem that didn't exist. If we do Shift V, we get visual line mode, and we can move up and down by lines. But you can see that nothing really changes if I use the left and right arrows. It still selected that line. Okay. Finding and replacing. This is probably the most complex thing we'll cover today. Oftentimes you're given a string of text that you have to find. It's probably the next use case that you want to get to. To search for a text within a file, you do /string. So /hello or whatever I have in my text file, it'll highlight that. Once all of those are highlighted, n, lowercase n, will move from my cursor position down. Shift N will move from my current cursor position up in my search results. So it'll move directionality, basically. And this is where the HL search will come in handy, because you'll see that highlighted. Now, the other thing here is, by default, VI searches case sensitively, which is kind of a pain, because especially if you're writing code and you're looking for, did they name the variable with an uppercase or a lowercase value or whatever. If you end it with /c, so it kind of looks like a tent, / the string you're looking for, / or \, and then C, that will make it case insensitive. So let's cover that, because the replacing gets even weirder. All right, so let's search for welcome. You can see that it's highlighted. There's only one instance of welcome, so that only one instance is highlighted. Let's say we want to go with hi. I've typed hi. Not only will it match the instance of the word that is denoted by the spaces, it will find that string within the word as well. So you can use a regex there to, if it's bound by white space, you can put the regex either way on either side of that, so you're bound by white space and then have hi. But by default, it will look for it like that. And we can see if we hit enter, if I do N, it's going to move. And then it gives you a note that says, hey, we've hit the bottom. We're continuing at the top and rotating through. So that is just, keep on forgetting that keyboard. You can see I'm just hitting N there. It's rotating through. If I do a Shift N, it's going to go backwards. And again, search, hit the top, continuing at the bottom, and rotating through. So it'll give you which way you're searching when you find all of those things. Okay. Now, let's go up a line here. Okay. Now, finding and replacing text. I've seen some really bad tutorials on this, so I want to make it clear. It's still weird, but I want to make it clear. If you want to find and replace a text within a file, :s/ what you're searching for and what you're replacing. This will find the first instance of that search string in the line and the line only and replace it. So I have that hi at the very bottom. If I want to replace that hi with something else, if I use this string, I'll only capture that first hi, because it's only looking at the line. Remember I said lines are their individual objects? That search will only happen at the line level. If I append a /g, so :s, search text replacement, /g, that is line global. So it'll replace all the instances of that within the line. Not inside the entire file, just in the line. You have to use :s to make it search across the file globally. So it takes every line in and replaces every instance. A lot of people will stop and say that /g, oh, it's global. It's line global, and that's why I emphasize that VI and Vim operates at a line level. And we can do /i to make it insensitive. We can do /c to make each change require confirmation. We can have /icg. You can stack each of those slashes at the very end to make it perform the behavior that you intend. So let's do this. And just to show you the line global here, let's move down to this one. And I'm going to do :s. We're going to search for hi, and you see it highlighted. It didn't highlight the ones that were not in the line because we're treating it at the line block level. And we're going to change that with hello. And we're going to make that global, so we're going to look for all of those. Actually, let's do C. We'll do confirmation. Let's do GC. So /G says we're going to look at the entire line. /C says we ask for confirmation if we want to make the change. So we'll hit Enter. Replace with this, yes, no. Replace with this, yes, no. And I'm hitting Y for each of these, sorry. Now, because I didn't have that %S, even though we searched for those, it didn't find them. It didn't change those middle ones in the other text. Now, if I want to do this globally, I want to replace hello there. Maybe I like hi better. I do %S/hello, 3 instances of hello, and I'm going to change that back to hi, and I'm going to make that global as well. I've replaced all 3 instances of hello with hi. %S is confusing. I know if you think global, but that's how it works. The last piece here that I'll cover is cut, copy, and paste. The only thing is Vim is a little weird. Cut doesn't exist. You delete it, and it stores it in a buffer, and then you paste it, which is essentially what a cut is. It's kind of deleted. It's in that weird purgatory state until you put it somewhere else. Vim just says, well, we're just going to call that a delete. So that's D. If you use DD, that's for a whole line. So like when I went back to the SSH key, :number, enter, DD, write and quit, in like 6 keystrokes, you've deleted that one key that was causing you issues. Copy is called yank. That one I don't know. So you yank with a Y, or you can do a YY for the entire line. That copies the entire line. Paste is normal, so that's P, and that'll paste on the line that you're at with the cursor. If you want to undo something, there is an undo. A lot of people say, how do I undo in VI? U. You just hit U. And that has a buffer that will fill up. I think the default is about 10. So you can undo 10 changes if you'd like, just by hitting undo. That not only applies for cut, copy, and paste, that means any changes, so those searches I made, I can do a U. It will undo those things as well. So let's do a quick demo here. Let's say I want to copy this line. So I'm on line 10. I'm going to do a YY. So I've copied that. I've copied that line, and I've scrolled up 2 lines there, and I'll hit P. It's pasted that line. Now you notice it did add an extra line because it maintained the integrity of the file there, because it's not going to say replace that line. That line exists as its own construct. I'm going to paste it below it. So again, VI operates on those line boundaries. Maybe I don't like that. I can hit U, and it will undo. So we're back to where we were. If we want to delete this line right here, I can just do a DD. That deleted that line. And maybe I want to paste it up here. I'll hit P, and let's move that up. So you can do some real quick editing on a line basis, just with the YY or the DD and then a paste. Real quick text manipulation if you're working with keys or something doesn't make, some config file or on your Linux system or whatever needs to be edited, you can do that really quickly with VI. So with that, I'm going to go away. I'm going to close. Wrapping it up. If you retain nothing else, if you want to take a picture, this is the screen to do it on. But again, I will drop this PDF in there. If you retain nothing else, I enters mode to write, escape to get out of it, write saves a file, Q quits, arrows to navigate, YY to copy a line, DD to delete a line, P to paste, :line to jump a line, and /string to search and to move results. That's the bare bones that you need to edit basically anything you need to within VI, and there's only a few things you got to memorize. It's not that hard. Plus, you can amaze your friends, and there's all kinds of customizations you can build inside of VI to make it look even cooler. I'm a daily VI driver. The only time you'll see me use VS Code is when I demo in front of folks, so they're focusing on VS Code and not the keystrokes. But I encourage you to look at those tutorials. If you're more interested, you can find me, you can ping me in the room. I'm going to drop that PDF in there. Lots of stuff here in Cisco U. With that, thank you so much for attending. One thing, before you all leave. Is this the ticket up here that's? Okay. Right in the front, underneath the... Oh, in front of the seat. There's supposedly a raffle ticket in front of someone's seat, or in front of a seat. Oh, okay. Well, you're finders keepers, I guess. Okay, right.
All right. So welcome to, wasn't expecting that. Welcome to Improve Your Digital Resilience with Splunk Observability. My name is Mark Hauser. And really just as sort of an introduction to the environment and to the topic, a little bit of background, well, certainly a little bit of my background. I am with Splunk, which means that I have been a Cisco employee for approximately 80 days. But I've been with Splunk for a little over 11 years, which is where I find on the title slide that reference to staff technical instructor makes me seem, I'm so new. No, it's actually the second level of instructors that we have. I think there's only 3 other instructors that have a higher level than I do. So hopefully, be able to answer any questions that you have and provide some useful information. Which also goes to, again, as part of the background, Splunk was acquired by Cisco. I think we all know that by now. That Splunk education is still separate from Cisco U, separate from Cisco education. So what I'm talking about is for Splunk products, not Cisco products, technically not Cisco products. So Splunk products, Splunk education, Splunk content. Specifically, what I am looking at are 2 components that we have available of the many products that we have within the Splunk line, which are for IT service management, service intelligence. Sorry, I had a little throwback to an earlier lifetime when it was ITSM. IT service intelligence, and observability. Now, another characteristic that I do want to point out is that this is not necessarily going to be a low-level technical discussion. It's fairly high level about what it is, not necessarily how it is implemented, which kind of goes to the second item in my introduction, which I have to appreciate. Someone else actually wrote this for me, but I like that second part about specializing in platform and configurations and developing, because that is my background for over 30 years, is working in environments for developing or implementing within the configurations of whatever that product is. Now, it's not necessarily at a programming level. Sometimes it is configuration, sometimes it's through GUI. So that's part of what we're going to be looking at as we go through these topics, is kind of touch upon what could be done, but again, keeping this at a fairly high level initially. Now again, let's take a step back for a moment. If we go back in history a bit, when I started with Splunk, there was no ITSI. There was no IT service intelligence. There was no observability. There were custom implementations of that type of environment, but not these products. Oh, and I also should point out that when we're talking about Splunk implementations, there are, because this is a question we've been getting quite often at the education booth, there are various licensing characteristics about Splunk. So there is the Splunk The Splunk operational platform has its license, and then ITSI would be a separate license on top of that. Observability would be a separate license from that. So there are these distinctions that do need to be made. But the reason I'm bringing that up is that there has been what I find to be a fascinating progression that, again, way back in the day, no ITSI. And by the way, if anyone calls it ITSI, that is inappropriate. It is ITSI. But ITSI was for identifying the concerns that we may have around the services of our of our servers and our services related to those servers. Now again, I'll talk a little bit more about this in a moment. But with ITSI, the level of detail that we had was limited. It was limited because of the speed at which we would expect data to arrive was more around seconds than milliseconds. So it was fine for its purposes, but we also wanted something that was a little bit more detailed, a little more real time. That's where the observability product comes in. So again, from the history, Splunk acquired the observability product. Cisco acquired Splunk. So it's a little bit of a chain going on. But we do have this full stack observability available for the variety of components that we're interested in. Again, whether it's for the incidents, for our infrastructure monitoring, for the application monitoring. Another little detail, again, a few details along the way, that for the observability, it is primarily cloud-based. For the ITSI, it is cloud or on-premises. So that there are, again, these opportunities for cloud-specific implementations, hybrid implementations, multi-cloud implementations, or, at least for the ITSI, certainly, there is the strictly on-premises implementations possible, which I've had, again, quite a few people come by the booth and mention things like air-gap systems. That's fine. It can be completely independent, doesn't have to be cloud-based, depending again on what it is you're trying to accomplish. So within the environment, again, the goal of ITSI, the goal of observability, same as many of the goals that we have within the products. First concern, and certainly this was brought up during the keynote this morning, absolutely appreciate this part, it's about the data. Right? It's about being able to collect relevant data, followed by doing something useful with it. Right? So that is kind of an important part, is what can we do with that data once it has been collected? So across all of the environments, we have this potential to collect information, whether it's through logs, through syslog collection. I'm going to say there's some discussions I'll have tomorrow about HTTP collection, HTTP event collectors, Kubernetes. There's various sources that we can have for that data collection so that we can have that detection taking place, doing something useful with that data. So again, there's the data collection and then doing something useful with it. Now for that data, even if it's cloud, it's your data. You've collected it. You've chosen what to collect. This, by the way, is one of the other characteristics on licensing, if you're curious on licensing, is that the initial environment, the Splunk operational platform, the licensing is volume-based for how much data you collect per day. There are some other variations possible, especially around Splunk Cloud, where there's a combination of how much data you collect per day, how much processing you're performing, and how much you are storing, because we are providing that environment for you. So within those products, and there is this kind of literally split screen, that we have observability and we have ITSI. Among the characteristics of observability, and again, if you saw the keynote this morning, there's definitely extensions, there's enhancements. It's going to go well beyond what we have today. But among the characteristics for both observability and ITSI is that not only are we collecting this data in order to have something useful from it, but knowing what the data represents, how the various sources of that information relate to each other. So again, during the keynote, there was some references to, well, if we have an outage in this component, how does that affect the rest of the business? How does that affect the rest of the components? And then we can drill down further into those details. That's part of the observability. That's part of ITSI, is knowing how that data interrelates. With observability, for instance, we can have tags that are associated with the data so that it makes it easier for us to retrieve that information. For ITSI, there's the services, then the components that make up the services, and these key indicators for what it is we're interested in. So that's one of the first items. Get the data, have something useful, meaningful from that data, but the relationships between those sources of information. Now for the observability cloud, so again, that observability component, there are several subsets of uses of the underlying information. Now the ones that we're focused on in these slides are the first two, the application performance monitoring and the infrastructure monitoring. There are also the other possibilities of the log observer capturing that information, the synthetic monitoring, real-time, real user monitoring. And again, with that information, there is both the relationships and again, the components that we have provided. But I also have to go back to the introduction again. My background is in how to configure environments. So certainly among the characteristics I appreciate about these products is that it's not strictly we give you something and you use it. We give you something that you work with us to make the decisions about what type of reporting is most critical for your purposes. So how do these items interrelate? Actually, should probably go to the next one. So how do these items interrelate? What kind of concerns are there within the environment? Now, another characteristic that we have, and I mentioned the tagging for assisting in the reportability of that data, but there are also the workflows so that you can link from the relevant information to logs, so we can drill down, get more information, have not just the metrics, but the underlying content associated with those metrics. I'll come back to that one. So we have the tracings, the metrics. There's also within, I have to remember which slides I have, that we also have within that reportability the alerts, so that if there was something that was unusual, and again, you get to define what unusual is, but if there's something that's unusual, you could have that flagged. You could get an alert, you could get an email. We can integrate with other alerting systems so that you do get that information when it's relevant. Again, speed, that was a concern at the keynote as well. Speed is important, not just for security, but for uptime, for managing the environment. Now, again, with the application performance monitoring, and by extension, I'll go into the infrastructure monitoring as well, it's not just a simple, oh, let's establish a threshold, and any time that threshold is exceeded, there's going to be an alert. Well, there's spikes that happen. spikes and then it drops back down. Something maybe a little unusual, but it's not persistent. So there are other constraints that can be defined for, does it need to remain above that threshold for a certain amount of time? Does it have to have several thresholds that occurred within a certain time period, so that we can have those restrictions so that we're not getting overwhelmed, we're not getting inundated with those alerts. All right, so again, configurable, customizable. Sarah mentioned the logs in context. Observability, as I said, separate cloud product. ITSI, so the IT Service Intelligence, again, built on the Splunk operational platform, which does provide that flexibility that it could either be the cloud-based environment, so that is our hosting, you just pay us for the storage and the computation costs. Does provide for some faster implementation, we do the installations for you. Or it could be your own environment. The Splunk Enterprise is what we affectionately refer to the Splunk operational platform when it's installed on your systems. So you manage the installation, you manage the configurations, or you hire someone from professional services to assist you with the configurations, but you manage or own the storage, you own the computation, you can determine the scale of the environment. Oh, suppose I should highlight that detail as well. The environment is certainly scalable, that we can have small implementations, one server that can handle everything, or we can have much larger implementations where there are servers that are dedicated to certain subsets of the operations and multiple servers to allow for more volume of data to be collected, additional storage that can be used in order to expand the overall content retention so that we could retain data for whatever time frame is appropriate for your environment, for your business. For instance, the default is to keep the data for 6 years. A little unusual, maybe. I know there's a lot of environments that there might be a 2-year requirement to retain the data. Then there's other information that is only needed for maybe a couple of months, right? Especially if we're looking at things like logs and debug messages. Don't need those once I've accomplished whatever the debug message is providing. So maybe we'll keep that for a shorter amount of time. Just had a gentleman who was, kind of surprised me. Someone came by the education booth earlier. They have a retention policy of 15 years. That's a lot of data, but we can handle it. We can handle that volume of data. Now within the IT Service Intelligence portion, and again, among the characteristics of ITSI is that we would define what are the services that we're concerned about, what are the components that make up those services, the entities, and then from there, well, the overarching single pane that we have initially for ITSI is whether those services are satisfying our thresholds, our control guidance for whether a component is out of normal. And so we can have, if it's reaching this level, we'll change the color to yellow. If it's reaching that level, we'll change the color to red. We'll let you know what those levels of concern are. And there are other configurations for selecting the color schemes and the number of colors to select from. So yellow, orange, red, green. So if it's normal, green, right? Quick reference, we can see it. If it's unusual, we can drill down. So we could drill down within the service to see what the underlying components are, what the related services are. So there is that similarity between observability and ITSI, where again, ITSI tends to be looking at less active environments where second granularity is sufficient. Observability, when we're getting down into the milliseconds of granularity, that's more effective, more appropriate. But they both have that characteristic of the relationships between the services so that we can see what the roll-up would be on if this service is impacted what other services are impacted, and conversely, if the service is showing impact, we can then drill down to see which of the underlying services was the cause, and then drill down further into the entities. Now, among the reporting options that are available, and of course, integrations are certainly available for the alerting, for interacting with incident management systems. The extensibility exists. Splunk environments are very customizable. But also, and this is where I get to use the term AI. So for this thing that is so popular and so new, well, we've had versions of it for quite some time, actually. From pretty much before I started with Splunk, way back in our reporting capabilities, we had the commands to perform a prediction on what would this value possibly be in the future. And so we can apply that within our predictive analytics. Now, let's take it a step further. Before AI, before it became that buzzword, before AI, we also had implemented machine learning. Sort of the precursor to AI is the ability to take the data and evaluate it, use the historic data in order to make predictions about what is happening, what may happen in the future based on what has happened in the past. That is part of ITSI as well, that we could apply those predictive analytics so that we can have those warnings occur before the thresholds are exceeded, before there are warnings, before there are people calling and saying, hey, we've got a problem. We can have those predictive indicators generate the alerts so that we can already be responding to whatever that issue is before it really, or whatever that issue is expected to be, before it actually becomes an issue. Another direction that this can go is with anomaly detection so that we can look for things that are unexpected. Now again, this is both available from a historic perspective to see what has occurred in the past. So seasonal changes, daily changes, things are different on weekends than weekdays. If there's some characteristic in that process that changes unexpectedly compared to the historic data, that could be flagged as anomalous. So we can provide that detail. But also, not to be left out for the anomaly detection, is that we could be looking at individual components, and again, it's part of that machine learning and some simple reports too, that we could be looking at those individual components, those entities that make up the service, and among the items, again, for that prediction, for that preparation to resolve issues before they become significant concerns, it might be that a service, it's on the next slide, it might be that a service has what appears to be a sufficient performance overall, but there's one system that is not functioning to its full potential. There's one system that is below threshold or above threshold, depending on your perspective. And that allows us to, again, identify for that cohesion if there is one entity within the group that is not functioning consistent with the other entities. Adaptive thresholds, actually I kind of pre-mentioned this one already. The adaptive thresholds is where we would look at that history to get insights into the seasonality, the daily characteristics, and be able to establish those thresholds in a more dynamic way. Now, like I said, this was this session was never intended to be deep dive technical, more high level characteristics, because we do have a lot of information that is available about these products, both within the pavilions, within the booths, within education. If you want to learn more about how to implement ITSI or observability, we do have our training programs available. There are certifications available as well, which do require the training. If you want to see a demo, I did, as I was walking through this morning, there is in the Cisco Splunk area, way over there, there is an observability podium where they do have some live demos available. Okay. Couple of things before we wrap up. Actually, I'll come back to the questions. Do remember to fill out the surveys. Also, by one of these seats, there is a raffle ticket. Looks kind of like this one. It's not this one, but it looks like that one. If you happen to have that raffle ticket, see the gentleman over to my right. We have a winner. All right. Again, don't forget the surveys. Any questions? Okay. Thank you.
All right. Hello, everybody. Welcome to the session. Thanks for joining, collecting data out of Cisco APIs. I have lots of stuff to talk about, so let's just get through the first slide here. So if you have any questions, there is a WebEx room, so you can, in your app, you can join this WebEx space, and then if you have any questions afterwards, so even now, just write it in the WebEx space, and I will ask the questions until June 7th or even further, so that doesn't matter. All right. First of all, I would like to start the goal of this session. So the goal is extracting data from Cisco products and services with the right tools. So I prepared lots of stuff on how and what kind of Cisco APIs are out there, and then what kind of tools are there specifically for these items. And with that in mind, I hope it's an interesting session. I'm trying this now with the GenAI push to focus more on the data extraction. And yeah, I'm happy if you have any feedback afterwards. A bit about myself. I'm Flo Pachinger. I'm a developer advocate at Cisco DevNet, and I'm focusing completely on data and AI. I'm usually based in Austria and Vienna, and as you see, I had created some project around data and AI in the past as well. With that, I would like to start, and usually my sessions are with the why. The why, because why should you extract data, or why is it important? Because right now you already have some dashboards already available, you have the data visible, why should you extract it? So let's dive in more into the world of data engineering. With that, first of all, a very important point is, of course, the integration, consolidation into a common layer. What does it mean? You have several components there. You have security components, data center with Kubernetes, with networking devices, and so on. And how can you make a decision based on that? How can you check the system health, or how can you track your KPIs appropriately? This is one common point in order to basically extract, consolidate, and harmonize all the data what you have. Another reason, and now coming more also to a GenAI direction, is about apply extended machine learning algorithms to the data. So the main goal is, the holy grail is to optimize and predict. Predict the usage, predict what is happening based on historical data. But you can also create new features or products out of it. So for example, you can use specific data for the GenAI chatbot there. Another thing is think about transparency among the internal teams. So you definitely have a visibility then into some areas which you didn't do before. And if you get data out of specific services in the cloud or even on-prem, you have 100% data control, which means you can set your own data retention time, depending on laws, depending on internal policies. This is basically you. And now, I would also like first start with the goal, and this is also very important, and one of the main purpose is, of course, what is the purpose actually of your data collection? So why should you actually collect the data? The first thing is about the why. Like we don't just like collect data just for fun, right? It takes some time, it takes some resources, it takes some budget as well. So think about that and think about like the business case and the use case at first before going more into I would like to get data out of specific APIs there. Number two is as well an important one, I would say, is what kind of skills do you already have in your team? Like there are a bunch of data engineering and data analytics tools out there, and most of them are like doing this similar job or nearly the same job. But if you have already some knowledge in your team, definitely go in this direction. So for example, if you have like already some skills in this specific database or this specific provider, just like focus, I would say, on this one, what skills you already have. Let's check also like where you are right now. So in this kind of way, there is like this pyramid of analytics. So where the main goal, the first goal is if you say it makes sense for us to collect data, let's start with collecting it at first. Which means like similar telemetry data, which means like configuration status. I will come to that in a bit. Then the next part is to clean and to aggregate it, because we would like to have a high quality of data. If you have some like nonsense data, some wrong data, it doesn't make any like good decision, right? Then the next step would be to analyze it. Analyze it like historic pattern at least, or like to check, okay, where are we right now? Where have we been like 1 week before? And the holy grail, like I said before, is about the optimization and even predict, like look into the future. Extrapolate the data and say, this is like our network usage, or like our prediction is that in 1 week we have a high usage there. Or especially on Friday, every time at 4 p.m. we have a high usage there. So this you can actually do with, like in the last part, with optimize and predict. But at first, always start like to collect, clean and aggregate, and then going forward there. Now, let's look at the architecture overview. I love the architecture slides. So first of all, and maybe you can relate there, you have like a bunch of devices. You have applications, users, the infrastructures, any things you have, right? And then platform and services where you have some sort of visualization layer. And if this is enough for you, and if you say, I don't need it, then it's totally fine like to just use the existing tools. Like I'm happy, like I'm a reuse guy. So the main goal is, of course, on the other side, like the business context is one of the really major goals there. Why should you do it? Like, are the decision makers happy with that? Do you have like insights to the health of the system? And the visualization layer is like, you can see this like a business intelligence tool. This can be a dashboard, like similar to that. And because like the time is limited, this is the session scope for today. So this is in the end, the session scope is how do you get the data from here to at least to the beginning of the visualization layer. And because it's like I wanted to make this very Cisco-centric, so useful for you, I created and aggregated some information on a table. So don't be afraid now like to see like a big table. I will go through this. So this is all products and services where Cisco has its APIs there. Not all, like I said, it's selected. And on the left side, you see like product and service. Like maybe you can remember, I hope you can remember or like notice some of these products there. And on the right side, you see the interfaces. So these are the interfaces where you can get the data out. And if you notice, there's lots of like REST APIs, which is like common industry norm. And then you see some streaming telemetry, remote procedure calls there, and also down there, especially ThousandEyes FD with open telemetry. And as you see, like in order, like some netconf and RESTconf is there as well. RESTconf in a way is also like some sort of REST API there. What do we learn from that, out of it? So we learn, okay, focusing REST API and webhooks. This is like one big part. And then also some streaming telemetry or open telemetry there. So with that, I would like to make this as useful as possible there. Let's start with REST APIs. So when you have a REST API, it gives you like the opportunity, it opens the door to many, many data. For example, you can get historical data out of it with some parameters. For example, t is equals day 1 or 1 month. So which means you can get data, for example, from 1,000 eyes, or which goes back to 1 day or even 1 month. In SD-WAN, you have even an API query language where you can get your SD-WAN data based on your specific query. And you can define everything this with REST APIs. Besides that, you can get out configuration parameters, health parameters, performance, user, and so on. So again, this, I give you like the framework basically, like how to use it. It depends on your use case. Like, is your data there? What is the use case? And what kind of data do you want to use? A good, if you say, okay, like how do I start? Like one start would be to go to the API reference. For example, developer.cisco.com/docs. You have here, for example, with Catalyst Center, all of these specific like GET requests and to see what kind of data you can get out of there. And this is like a cool thing when you have like the REST API there. Another thing what I would like to mention, and it's just one slide, although you can talk about it for like several, you can have an only session about this, is OpenTelemetry. So this is about an open source observability framework. And the cool thing is, and this is why it's like a really brand hot topic right now, it's a vendor and tool agnostic. So which means, if you look at the graphic here, you can get from microservices, from any kind of microservices, because you have an SDK and API there, then from the Kubernetes stack, from layer 7 proxies, from your shared infrastructure, you can get all the data in a vendor and tool agnostic OTel collector, in a collector, and via the OTLP protocol. And with that in mind, you can then feed with specific extractors this OTel collector, the data, to a time series database, traces database, column stores, whatever you like. So just for you to understand, there is a collector, and with that, you can get the data out of this, and this is like a very hot topic right now when it comes to streaming. With that in mind, moving forward, I would like to give you like an overview on the difference between batch and stream processing there. So first, you have the batch processing. And I would say this is like applies at least to our REST use cases. So you have the source there, which is usually the REST API or the interface, and you would like to get the data to a destination. So usually you can set an interval, like a fixed interval there, in order to move the large volume or larger volume of data to your destination. When it comes to streaming, and this is more telemetry streaming, open telemetry, you get like from the source data to the destination in a continuous stream. So this is basically what you have there. So moving forward, like just also like some other basics there, and then I'm going more into the data engineering toolset. So last slide about the data is about there are different types of data. So first of all, like there's structured data, with a predefined structure, like a relational tabular data. Then maybe most of you are familiar with this, like JSON data or XML data, which is like semi-structured. And finally, you have like unstructured data, so which is any form of data, mostly with GenAI, and then here, especially with the logs file, like any kind of text files you have here. So this is like for you just to know that you can store data in these specific forms, and this is like also for you to remember in what you would like to achieve, but in a way, this is kind of like the types what you have there. And now, I would like to introduce you more about the extract, load, and transform data pipeline there, how it's usually used. And based on that, I have prepared after this some examples how you can apply it actually in the Cisco environment there. So first, we've seen it before, like they're data generators. Like for example, like I said, your system, your logs, your applications there. And you ingest this usually into like some sort of data storage. So this is like a data lake. This can be a data lake house, data warehouse. But like for now, let's leave it at that. This is the storage. The most important part is there, like what is the time interval there? Is it like a pull-push time interval? Like do you pull the data or do you push the data there? It is, what about latency? What about the throughput? What about the volume of data? That's also very important in order to get the data into then the staging area. So first, you pull the data into a specific staging area, which means it's like an S3 bucket, which means it's like some storage there. And from this area, you actually go to the data processing part. So this can be done with Splunk, and then also with Apache Spark, but I will come to that later on. And then the outcome or the goal of us is like this golden table there, where the good data is, but like where the high quality data is, where everything is already prepared. And here again, like this whole process is again very important about variety, what kind of data you have there, what kind of data you're pulling from, the quality, very important, and of course the transformation and which kind of format it is. So I talked about the data structures before. Do you like relational databases? Is it like more about unstructured one? Again, you need to dig deeper there into the use case. And the overall goal is, like I said, in the business context. Business intelligence tools, for example, these are the dashboards and the visualization part there. So with all of this, like with the data pipeline, like it's a high-level overview, and maybe, or like I hope you will ask yourself now, hey, okay, that sounds really cool in a way, but like how do I start? Like how do I get from there? And with that, I have actually, again, selected some data engineering tools, which I would say it's a good form to start, and that you can basically start on your own, and again, with any kind of Cisco tool you have. So first would be the data messaging and ingestion. So a lot of data engineers, and maybe you're surprised, are actually using just plain Python in order to get data out of the devices, and then in order to process this even further. So there's nothing wrong with using just like simple Python. If you would like to scale it up more into like a distributed system, or you have like tons of transaction data and transaction logs, then there are like other tools there out there. For example, Apache Kafka, very data messaging tool there. This is more about like event-driven microservices, but also distributed systems there. And when it comes to RabbitMQ and ActiveMQ, like this is a classic traditional message broker. So this is again just exchanging messages there. So it really depends there on the use cases what you would like. But if you say, hey, I don't know where to start, just start with simple Python, and that is enough, I would say, from the start. For the data processing part, again, pandas and polars, which are Python libraries. This is, again, something where I would definitely recommend. It's totally enough. It's really enough to go and start with Python frameworks there. And then if you would like to go more forward into like a production base and into like a really high quality tool, then Apache Spark, very powerful tool. You need like your own clusters there in order to like to get your process your data there. Or even Splunk is available, you know, like to get the data out there into Splunk, and then Splunk can do its magic there. I will briefly touch on data storing. So like Postgres as the relation database, MongoDB in a way of to have like a more document storage there. InfluxDB and Prometheus as a time series database, right? So like we deal with lots of time series data. So this would be like my first choice if it's about time. So like if you're collecting data over time, the last two are definitely very important. And one important part which maybe gets a bit underestimated is, last but not least, the process orchestration. And there are some tools out there, maybe you've heard it, it's about Apache Airflow, Dexter, and Mage. Like this is just a selection of mine. The most popular tool, one of the major one and mature one, is Apache Airflow. So with Airflow, and I will have a demo on Dexter in the end. The main thing about Airflow is that you can, and this with a Python library, with a Python framework, create your own data pipelines there. So you don't use your custom Python framework. You can just use one of the process orchestrations, and it even comes with a nice UI there. With Dexter, I have a demo in the end planned there. All right, but now let's go further, and let's say you have a first project, right? So the first project, I would say, if you'd like to say, hey, I would like to get some data out of it, and what do I do then? So first of all, one of the main part is data exploration. So in the end, it's about just like get some data, just some part of it, use it with Python and a Jupyter Notebook, and then basically like pull it out. Like Jupyter Notebook, you have a Python environment in the browser, and you can elaborate and explore the data more. So basically you have like here some nice graphs with matplotlib and so on. So you can visualize your data there. And the frameworks here I would use as well is like pandas and polars, which is like pandas is like a more mature one, and polars is like a rising star because it's like more performant than pandas apparently. But in the end, like I would say, start with pandas because it has like more learning content there available for now. If you're saying, okay, this is now done, and you have like the Python project there, then you can move up and go more to a streaming high-volume event data. So, for example, you have here like Thousanders instance. Your AppD, like your applications are getting monitored with AppD, like the traces. This will at first come with a classic OTel collector and then into a Kafka broker. Or you can stream like directly from iOS.exe or from any third party into the Kafka broker, into the ingestion. When this is done, you can do some processing there, like this is done, for example, with Apache Spark. Or again, if it allows, you can actually do it with simple Python, because in the end, it really depends on your memory usage, your CPU, and how long and how big the data is, of course. Finally, you can store it, and then this is the visualization part. Another example I have here is like extracting data with Python, like a classic one. So like I did this some time ago, which is basically getting the data with REST APIs in a fixed interval into an influx database, and then to visualize it with Grafana. And this is like, again, why did I do this? Because Thousand Eyes dashboard has a really nice interface, and you can see it and have a good visualization. But in the end, the use case was the customer wanted to integrate it into his own dashboard there. So what does it do? It is a custom Python code. There is a Linux service around it. So basically, it spins up every time. And then the data pulling interval is defined in the Python connector script. So it just pulls the data there, forwards it, and inserts it into InfluxDB, and then you can visualize it in Grafana. And now the thing is like this. There is like no framework. So the downside is it's very easy and a really cool POC, but you have no framework. So it's like you need to maintain the code. You need to basically like do everything on your own and write everything from scratch. It can get complex, right? Like with that, it can get a bit complex there. And this is why, in the end, it's like good to work with some tool, with like an orchestration tool. So with that, I would like to check like Apache Airflow. I didn't choose, like I chose Dexter because it's like more newer, let's say, or more cloud native oriented. But in the end, it's of course your choice. What would you like to choose? The cool thing about Dexter is it uses a directed acycling graph, which is basically like this. You have here a directed acyclic graph, doesn't have any cycles. So this is perfect for a pipeline like this. So it starts with A, it goes through A, B, C, D, and always, every process or after every execution of the node, it ends with E. And this is like what you would like to have, right? You would like to have everything in there, parallelization as much as possible in order to see it there. And this is then the outcome with Dexter. And I've prepared a demo here. So let me just open here the source code there, how you can view it. So with Dexter, it's like this. You define an asset. An asset is basically like one step or one node. And with that one node, I just said, okay, get the data from Catalyst Center. And this is basically like, I get it first a token. I get it first, like get network devices with the token. And then it doesn't do any compute in this section here, in this function. It actually returns it and gives it forward to the next node. So basically, like I have some node here. The next one is the next asset is clean the data. So this is like what it does with, if the issue count is more than 0 or the overall health is less than 10, then please forward it into the next step. And then finally, insert into a database. I would like to just put the data into a database there. And now let's spin up Dexter. So it's very easy because you just like can run your development environment there. So it's spun up, and then I'm loading it. So here you have like an overview, and I have here the first group name with Catalyst Center. So when I click on it, I actually see here my pipeline, which was created like out of the Python code. And so instead of using custom Python, I have a nice UI, I see the code already, and nothing is materialized, which means the code wasn't executed yet. So what I can do is like I materialize all, so the code is running now, so like I launched it, so you can see it at first, it gets the data from Catalyst Center, and then it should clean the data, and then it inserts the data into the database. When you would like to know more about, you can view it in the logs, so you can see there that, okay, what happened. I also put in like the data what got pulled. You can see it here. This data was pulled from Catalyst Center. This is actually pulled from the always on sandbox there. And then let's see if it got ingested into the database there. So I'm opening it into the SQLite database. And yes, you can see, I hope, yeah, that this data got inserted, like these 4 points. The overall health and the issue count was ingested there. The cool thing about this as well is the following, that you can, in the overview, you can actually have schedules. So basically you can say, hey, please run this specific job every minute, for example. So if I put this here, it is actually a service and it pulls all the time, every minute, the data into the database. And if you need to have any specific like runs and you would like to have why, like some failures, why it didn't run, you have here a really nice overview to see what happened, why it didn't work, and so on, and how long it took as well. All right, so with that being said, what are the key learnings and recommendations I can give to you? First of all, always ask before what you want to achieve. So this is very important. Don't use any tool. Kafka sounds fancy, let's use it. Kafka can be super powerful and overhyped sometimes, so I definitely check this. Use the most suitable tools to each use case, so this is also very important there. Then build on the skills of your team, what I said before. So if somebody used already in your team Airflow already, then don't use Dexter in the end, just like build on the skills on the team what you have. And of course, like, do you have already some data engineering team within your company or some data science team? Definitely work with them, because they already have the infrastructure there, which will definitely help you. With that in mind, I hope you enjoyed the talk. I hope this gives you something out of it. I'm really interested in your feedback, good or bad. I would be happy to receive it in order to see if this is something what, especially with the Gen AI hype, is something interesting for our audience here. With that being said, thank you so much. And before clapping, like there is one thing, you can win a chance. You can win a prize. So if you look under your seat, you should find a blue ticket there. And the lucky winner should then come to the stage on the left. If you can find or whoever is the first to finding the blue ticket there, then you can win all some prizes there. Let's see. Do we have a winner? Oh, there you go. We have a winner. Awesome. Perfect. Thank you so much. All right. Thank you so much. Have a great Cisco Live. Thank you so much.
Hello, everyone. Welcome. My name is James Risler. I'm here with Doug Notini, my pal. We're here to talk about lessons learned from custom zero trust training development. If any of you are in the DoD space, you probably know it as C2C. We love acronyms, right? Comply to connect. It's nothing more than zero trust. So if you need to find me, you can find me at Jim Risler on Twitter. I'm also on LinkedIn, and Doug's going to talk a little bit more about himself a little bit later. So we're gonna jump right in, keep you guys stimulated. All right, you know the drill. You've probably seen it a couple hundred times. So fill out the surveys. We love the surveys. It's really a good opportunity for you guys to give feedback to us about what you want to see, what you don't want to see, so we can adjust for next year. All right, so we're going to talk about why C2C training, all right? Then I'm going to jump into why we do custom training. So a lot of people don't know, but Cisco Learning does custom training. So if you have a problem, come to us and talk to us. And then we're going to talk about defining job roles. Once I'm done with job roles, I'm going to pivot over to Doug. And Doug's really going to be the guy who's going to lead us to the end, to the promised land. So he's got the train ready to go. All right, he's going to get into C2C challenges, knowledge, skills, and abilities. And then he's going to bring us all home with the learning path. So we did in a little thing called Cisco U. Repeat after me, Cisco U. Great thing, great tool. All right, so for the best return on your money, pour your purse into your head. Famous quote from a famous person. I don't know who it was. Might be the guy who got electrocuted, Ben Franklin. So great Apple streaming series right now going on with Benjamin Franklin. So why custom training? A lot of you have challenges where you're trying to do large-scale deployments. Maybe you're trying to deploy, we used to call it AnyConnect, and you have people all over the world. You got to customize AnyConnect. We've done all kinds of projects around custom training to where it allows you to be focused on what your business does rather than all the other minutia, all right? So we can align the training to your business. We can define it around the business needs. We can incorporate your own content into the training. So maybe you're doing a specific version of a solution that you've customized. We can put that in there. So your zero trust implementation might be with a couple other vendors. We don't care. We want to partner with you. So you can bring those vendors to the game. It gives you flexibility. It allows you to deploy faster too. And it can be job role targeted. So I'm going to show you some job roles. How many in here with show of hands know what DoD 8140 is? 1, 2, that's it, 3. So DoD 8140 is KSAs, knowledge, skills, and abilities, work roles. That's what we're going to be talking about here as well. So how many are interested in custom training or think that might help you with a problem? Nobody? Yeah, a couple people? All right. Thank you for playing along. There will be prizes later. All right, so this is kind of a brainchild, a slide of mine right here. I always think about this me being my brain, basically funneling data into it, but now it kind of looks like that, but it's really talking about you guys are the orange box, feeding the data to Doug and I and the team, and I see some of my team members out here, and dropping it in, and basically what we do is we create the training at the end of the funnel. And then you review the training, we digitize it, we make it e-learning for you, or we can make it ILT, and then we allow your instructors to go provide the content. Here's the killer thing about this. It simplifies the learner experience to what you need. It automates real-time purposes of reporting, badging. We can do badging. We can do exams specifically for you. You can write the exams. We can put your own videos in here that are specific to your company. And then we can give you accessibility visible to all the data so you can track your employees. Did they do that training? Because a lot of times they just click, 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 click through the training. Well, if you have a quiz in there, or an exam at the end, you'll know, and then we can show you along the way how they did in progressing through the content. Is this making you excited? I know I'm not a John Casablanco kind of instructor, but is this working? Nod your heads, please, just fake it, all right? All right, thank you. All right, we're gonna jump ahead. We got questions coming up later. Okay, who should consider custom training? Notice the people are already bolting out of here. I love it. All right, organization with mixed solutions. I already mentioned that. So if you have that P company or that F company or somebody else, we'll work with them. We get it. Most security companies are like a plane flying along with thousands of pieces attached to them. You don't have just one security vendor in your company. So that's just an example. You got to work through these problems, we're here to help. And we'll help you with your DNA. It looks like helix, doesn't it? A double helix. So we can do mix of IoT. We can make it IoT, ELT. You can have students all over the world because we can scale out. We can take big companies, we can take small companies. We're here to help you. So whatever your training need is, if it's got Cisco components, we can help you with it. We can make labs. We can customize the lab environment. So if the lab has to be around a very specific solution with zero trust, let's say you have a vendor with Cisco that you're doing, so you're doing identity services engine maybe with a couple other vendors for a wireless solution, we can build the lab for you. So I'm trying to get you guys to think outside the box of what you may need for custom training. Custom questions. We can do videos that are specific to your solution. What do you think? Yes? Interesting? Maybe? All right. I'm getting a lot of blank stares. That's usually a scary sign. It's like, is he going to get to the good stuff? Yeah, good stuff is coming up. Here's your people in your company. So you have a Maria, you have a Manny, you have a Sylvia. They might not have those names, but they're doing job roles in your company. Maybe they need to upskill. Maybe you need to give them new training. Maybe you have something that's very specific, like a mandate from the federal government called Comply to Connect, that you got to get deployed. And you're trying to figure out, how am I going to do that? Well, you're about to learn, because we're here to help. I've been there, guys. I've worked for Disney, so I get it. You know, you have to get stuff deployed, and each person, your team is your biggest weak point. All right, so I'm pretty much done with my piece, but there's KSAs, knowledge, skills, and abilities for each person here, right? And we can map those out and then customize the learning path training for those individuals. So now we're going to get in the good stuff. I was just the nice guy brought in. Now we've got to bring in the hammer, all right? So, but before I do that, think DOD, NIST, the National Institute, the 800-181 work roles. Take a look at those work roles. They might help you train your team. I'm doing a lot of work on those work roles, so take a look at those job roles out there and see if those knowledge, skills, abilities help you fill in the gaps in your organization. So think. All right, let's get into the lessons learned. Here comes Doug.
Thanks, Jim.
Tag.
I'm it. Audio good? Welcome. So what better way to start off the presentation than with a CrossFit slide? Any CrossFitters in the audience? Okay, for those of you who are CrossFitters, you can help me out. For those of you who are not, that's okay. Here at Learning and Certifications, we're all about knowledge transfer, so maybe you'll learn a little bit about the CrossFit sport. Quote, there's no substitute for hard work, Neil Maddox. The gentleman on the left is Neil Maddox, and in the CrossFit world, he is an elite athlete. He goes to the games, he competes, he's phenomenal. I've had the pleasure of dropping in on Neil's gym. In CrossFit, we call the gym a box. Had the pleasure of dropping in his box several times in San Jose throughout my various travels. He has given me, hands down, the best advice of my CrossFit life. In the middle, you see my current CrossFit gym in North Carolina, one like so many across the country. And on the left, I stand with John Harper, who's a Special Forces trainer. He's also my current coach in North Carolina. My name is Doug Notini. I am the leader of the security content development team and learning certifications. I'm also the subject matter expert in ICE for learning and certifications. And in today's high-tech world we live in, where the demand for custom training is only increasing, it's important to stay sharp, to stay focused, and to deliver quality custom content. It could be said that preparing to deliver custom content is a lot like preparing to do a workout of the day in CrossFit. See, in CrossFit, we listen to our coaches. Why? Because they are experts in the field. They've been there. They've done it. They've got excellent advice. And you're going to need that advice because you have to develop a plan of attack. If you want to have success going in, you have to really have that plan to get that success coming out. And then after all of that, listening and planning, it's down to execution. If you want to get the appropriate outcome, the plan needs to get executed properly. So listening, planning, and executing. In a lot of ways, learning and certifications is like a successful CrossFit athlete, which brings me to the main message of this presentation. Here at Learning and Certifications, we have the expertise to listen, plan, and execute on custom content. And you're going to see those lessons applied as we take you for a walk through the journey that was custom content creation for Comply to Connect. So next up, let's take a look at some of the development challenges we had with Comply to Connect. Before you act, listen. Hemingway offers fantastic advice, which we absolutely employed as we looked at some of the development challenges associated with the project. When I first heard about the project, it was actually from Jim. Jim's being very modest. Jim and I met, and Jim presented me with a Word document. In the Word document was a high-level overview of an ask for some training. From that, we could glean that couple of things. 802.1x is a technology, as well as the Cisco ICE Identity Services Engine were going to be key components of the Cisco Comply to Connect solution. In addition, in that document was the beginnings of an outline for some training. To be sure, it had some holes in it, some things needed to be filled in, some gaps, but it was the beginnings and we could build from that. And another section of the document that I thought was extremely helpful was a section titled Cisco Subject Matter Experts, Cisco SMEs. There were 3 names that jumped out: David Risch, Chris Eckhart, and Nathan Falcon. All 3 had spent time going base to base, talking to the folks, educating them. So I realized if I'm going to listen, I've got to listen to these SMEs. And we set about doing that. It just so happened David was in RTP, North Carolina, which is what I call hometown. He was in town that week, so we went out for dinner. And we had the first of many meetings that we continued through WebEx. And during those meetings, I listened. I listened to what David had to say. And this is what came from those meetings. There's a real requirement in terms of Comply to Connect for training. Cisco in Comply to Connect has competition. And one of the big differentiators that we saw in that space was our ability to come with training. The ask was for both e-learning as well as instructor-led modalities. Now, we happen to be an agile content development team. I lead that team. So we have an initial focus on e-learning. Jim mentioned our flagship e-learning platform, Cisco U. This is where folks can come and get access to content, get that acknowledged transfer. I'm happy to say as I stand here, the e-learning component of the Comply to Connect learning path is going to be available very shortly on Cisco U. So mission accomplished there. And once we do that, we turn our attention right to the instructor-led component as well. So We were happy to hear that that was an ask, and we had a good solution for it. Another thing that came out, though, was the whole idea of, as the guys went base to base, the Cisco SMEs went base to base, they were talking to those on the base and educating them about the Cisco Comply to Connect journey. You see, C2C has specific steps. Those of you familiar with the project understand, step 1 through step 5. And there are products that go hand in hand with those steps so that you can get yourself down the road on Comply to Connect today. What David and the SMEs were telling us was that zero trust architecture as a model, it's phenomenal, right? But it can be a little abstract. Far better that you journey with Cisco down the Comply to Connect road using the technologies and steps that are available now. Because if you implement those, you're going to find at the end of that journey, that C2C journey, you are oh so much closer to that ideal of ZTA, Zero Trust Architecture model, making it a journey well worth taking. So what did we take away from that? I took away that we need to tell that story, the story of why Comply to Connect and why Cisco and Comply to Connect. That had to come through and resonate in our custom content training. And you'll see that as we take a look at the learning path. In addition, we have a need to address some of the evolving products and solutions that go along with the journey. In the interest of time, I'll mention one. If we have some time later, we can get to others. The DoD has additional requirements for reporting. And the CX engineers here at Cisco have developed an application that really works hand in hand with Cisco ICE to get the job done. So as we listened and we heard about all of these stories that the Cisco SMEs told, we knew we had to focus our content and our custom content training to address these areas in the solution. Which brings me back to the main message here, right? Learning and certifications, we do have the expertise to listen, plan, and execute. Next, let's take a look at knowledge, skills, and abilities. Give me 6 hours to chop down a tree and I'll spend the first 4 sharpening the axe. Love this quote from Lincoln. It speaks volumes to the idea of planning, which was the next phase in our content development effort. So we went from Word document to Excel spreadsheet. We took a look at existing content, which we had plenty of. We were in really good shape because we had good content on 802.1x, and my team had just finished an entire project on uplifting Cisco ICE. We were now at 3.x code, which is exactly where we needed to be. So one could say our existing content was hot off the press. But we didn't stop there. We took a look at everything, all 19 courses, modular courses. We laid them out on a spreadsheet. And along with the Cisco SMEs, we went through topic by topic because we wanted to get down to brass tacks. We wanted to deliver that quality content that the Cisco SMEs needed to go and deliver the training to the DoD. So topic by topic, we sort of whittled things down. And I'll cut to the chase. What we came out with in terms of the learning path I'm going to present, about 80% of the content we found from existing was A-OK. 20% of the content we needed to do from the ground up. So it's about an 80-20 split. 80% existing, 20% new, you're going to see in the solution that we came with. The other thing that came out of conversations, in terms of planning, was the idea of multiple tiers being required. So we mentioned, KSAs. There were different outcomes that were needed. Tier 1, more for the entry-level folks. Tier 2 for mid-level. Tier 3 for the advanced. So while we were going through that Excel spreadsheet, we took a look at every topic, and we had a lot of debates, discussions, back and forth arguments, and then finally we'd come to agreement. Is it Tier 1, Tier 2, or Tier 3? And then you'll find we rolled all of that up to the course level. So when you get to the learning path, you're going to see, is it a T1, is it a T2, is it a T3? We have all of that accounted for. But we didn't even stop there. We talked about time phasing, because that's another requirement of the DoD. A lot of levels of complexity came into the project. We knew that there were some things that were fully baked today, and we could deliver on those. I mentioned that a key differentiator for us was training. We had to come with training sooner than later, and we did. So the things that were ready, we made part of phase 1. You'll see that. And when I say that we're pretty much there in terms of our content, I'm talking about the phase 1 content you'll see coming up shortly in the learning path. Understand, though, that after phase 1, there's phase 2, there's phase 3. So did we come up with a plan during this phase to address those as well? We did. You'll see that baked in. And then C2C specific requirements. I mentioned the DISA reporting. There are others. So where this really reflected was in some of the newer content you're going to see in the learning path. Cisco ICE as a product has the ability to address things like certificate-based authentication to ICE, common access card, CAC card authentication. Been able to do that for a long time. But in terms of our existing content, in the commercial world, that's not necessarily an application one would see. But for the DoD, okay, we understood we had to do that. We had to add that component on in, and we did. And there were others, things like custom profiles in ICE had to be added in. There's a brand new extensible authentication protocol supplicant being used by the DoD that we didn't have in our existing training. So all of those C2C specific requirements we added in during the planning phase as well. So once again, I'm going to say that we here at Learning and Certifications really do have the expertise to listen, plan, and execute on custom content. Let's take a look at the learning path. The learning path that you'll see on Cisco U is broken out into tracks, and you can see these across the top. A track is nothing more than a logical grouping of courses. We have 6 tracks in the learning path. You're going to see that in the 6 tracks, we have 18 courses. 14 of existing content, 4 that are new. If I look at track 1, this is the C2C fundamentals in 802.1x. Remember I mentioned the why and the how, and we got to tell that story, and it has to resonate, it has to come through right away. This is where you're going to see that story told in that course. Okay, we've got that C2C journey, all of the ways you can go through and the various steps that you'll take. That comes through loud and clear, and then we follow it up with the rest of the track being on an introduction to the .1x technology and how to work with that. From there, we move to track 2. In track 2, we start shifting our focus. The focus is now Cisco ICE, which is our flagship security product that is oh so important in the Comply to Connect solution. Here we take a look at things like architecture and deployment. Track 3 gets into the nuts and bolts now. We start talking about AAA, authentication, authorization, accounting, all of that. How do we go through those policy components? Here you run into one of the courses I mentioned, PKI and advanced supplicants. It's tunneled EAP. Brand new EAP chaining technology available on the Microsoft native supplicant now. Wasn't available before, but again, the way we customized to make it so that it fits exactly what the customer's needs. Added that course on in there in track 3. Tracks 4 and 5 are just oh so essential to Comply to Connect. One of the tenets of Comply to Connect is if I don't know what a device is, it doesn't get on the network. So we have to address that with the ICE profiling functionality. And then in track 5, it's not just about I know who you are, it's posture checking. Do you have the appropriate configuration on the device? Okay, is the firewall installed? Do I have the antivirus software? Are all the compliance checks made? Because once again, with zero trust, it's very binary. You're either allowed or you're not. And so posture checking is a quintessential component of that with ICE. And then in track 6, we get to those C2C specific use cases. I mentioned CAC card authentication, right? Things like that. And we talk about those other specific use cases. So here, what you'll find in terms of phase 1, like I said, 4 new courses, 14 existing. If you look at the 18 courses, 8 out of the 18 are at tier 1. So just a little less than half at tier 1. You'll find another 7 are at tier 2 from a KSA perspective, and then 3 are all the way at tier 3. But we didn't stop there. This I mentioned is phase 1. Okay, as I fast forward one slide, you'll see phase 2. I mentioned we are an agile development team, which means we love iteration. So as requirements get firmed up, there is some fluidity in Comply to Connect at this point, or as you get products that are more mature. Okay, we have a solution, a custom content solution to address those changes, and you'll see those as we look here at future phases. So we're talking about in track 3, uplifting some of the Cisco ICE policy components there, as well as the troubleshooting. Out in track 5, some of the posture services. One of the cool, nifty things in 3.2, ICE 3.2, is the ability to do scripting for posture. So that's going to help in terms of automation, which is a key component in Comply to Connect. It's not just making sure things are secure, it's finding ways to automate that. So as those requirements do get firmed up, we have the intent and the ability to execute on that. And you'll see other custom content here as well for additional C2C use cases. All right, so it's going to bring me all the way back to that main message again, right? Here at Learning and Certifications, we really do have the expertise to listen, plan, and execute on custom content. So the ask is, the next time you have a custom content need, come to the experts. We will deliver quality custom content for you as well. Thank you, and I think now it's time for questions. Any questions? So I think the question is, are we taking into consideration some of the requirements for next steps in the future? And I think you mentioned a few things that were specific to encryption. And so, yeah, one of the things, thank you for the question, first off. So one of the things that we're cognizant of, and it really came out, we had numerous meetings with the Cisco SMEs. And I mentioned 3. I've probably met 3 times as many Cisco SMEs in terms of the time frame we've spent. So it was clear that some things we could do today, and that's where we got into the phasing, in phase 1. Honestly, some things were not as fully baked from a requirement perspective, and even maybe from a product perspective. So things are evolving. This is where we do have, and we will continue to have those discussions with the Cisco SMEs, and they will bring to us what the next requirements are for phase 2, and we will address those. So to be sure, we do have a future-proof plan for this, and it sort of plays into our wheelhouse as an agile development team. Thanks for the question. Anybody else?
That's a good question. I like that question. Doug and I have done a lot of custom development together. Sometimes in these custom development scenarios, you'll get a situation like she brought up. What about encryption? Sometimes what you want to do is you want to build a lab environment and start working through the scenario and figure it out, right? And then what we use is that lab environment to drive the training. We build the training to that, like plan, design. I love the quote he had up there about Arnold Schwarzenegger. How many of you saw that? That was a good one. So thank you guys very much for coming. We'll be here to answer questions. See Doug, because he knows a ton. Thank you
very much.
Hey, hang on. Guys, we're giving away a prize. Somebody has the ticket under their seat. Oh, looks like we got it.
All right, good afternoon, everyone. Everyone hear me okay? All right, everyone's here to talk about NetBox? All right, first of all, my name is Palmer Sample. Today's session was supposed to be presented by Rich Bibby, who is a technical advocate at NetBox Labs. Unfortunately, he had an emergency and had to leave the event early, so I'll be presenting for him. And so, you know, from all of us here at Cisco, we want Rich to know that he is in our thoughts. So today we're going to be talking about modern network automation using Ansible with NetBox and Cisco Catalyst Center and Meraki. We're going to be going through a little bit of history with NetBox, what NetBox is, what it's for, some of the ways that we can do modern network automation. We also have someone special with us from Red Hat. She'll get a chance to introduce herself in a few, and then we're going to do a demo. So that being said, if you have the Cisco Events app, there is a link down here, join the discussion. If you wish, you can click on that. That will add you into a space where you can continue the discussion in WebEx. So again, we're going to be introducing NetBox. We're going to be talking about reference architecture and moving through to a demo. NetBox Labs was founded in 2023 in New York City. They are the commercial steward of NetBox open source software. And it's a world-class team that built and led NS1, which founded the NetBox project. And of course, world-class investors and especially customers. NetBox is a network source of truth. Has anyone here ever heard the term source of truth? Source of truth, all right, not source of data. It's not a spreadsheet. You know, we're talking about an actual system which is going to store the desired state or the intended state of our network, of our devices, our IP addresses, everything that we need to document our infrastructure. And again, I need to point out, the intended state is different than the operational state. When I say intended state, I mean this is what we have documented, what our network should look like, all of the links, all of the devices, all of the connections. This is how it should be. And we use that intended state or desired state to derive network configuration and ensure that our network is compliant. Operational state is how is the network actually running right now? What is configured? What is operational? Is my routing protocol up? You know, we derive that from our source of truth. And once again, or pardon me, it's a comprehensive data model. You know, it's got a very comprehensive database model. We have objects in there that have strong relationships between each other. So for example, I can tie devices to a location, locations to sites, interfaces to devices, VLANs to interfaces. So we have that strong relationship which actually allows us to build that comprehensive documentation. And here's an example screenshot. We're actually going to be looking at NetBox that we're going to be using for today's session. But it's the system of record. You can see we have everything that we need to configure, you know, in this case, a site. So once we have this site configured, we can then attach devices to the site. We get rid of spreadsheets, and we break the barrier of data center infrastructure management and IP address management. So everything is in one system. We don't have multiple different ways of tracking things like my famous hand-built spreadsheet that I used to use for IPAM that I spent hours on and never got updated. Once NetBox came into my world, then I stopped doing that for obvious reasons. And a very important part here is it's a source of truth for network automation. We have REST APIs, we have webhooks, GraphQL, everything that we need to actually interact with NetBox, not just as humans with the UI, but as part of our network automation strategy. And once again, everything is correlated. Those database objects have those strong relationships. When we want to implement a network source of truth, it's not a simple, 2-hour job. Depending on how many devices you have, it could be. But we're going to start with documenting our network. we need to converge our legacy sources of truth. That might be asset management. That could be our spreadsheets with our inventory. It could be our IPAM spreadsheet. It could be something that's in my head. But we need to actually get all of that into the system so it is our source of documentation. And then once we have that up, then there are plugins available where we can discover more information about devices, import that into NetBox, or we can add that manually. Depending on if there are actually other integrations for some other systems to pull in that information as needed. Excuse me, it's only day 2 and I'm losing my voice. I love being in the desert. And we need to change our operational processes. What I mean by that is, how many of us write all of the documentation before we make any changes to the network? I see a couple of hands being raised. Notice I didn't raise mine because documentation is always a last resort. So we need to change our process. So the first thing that we do is update that intended state. And again, our configuration is derived from that intended state. Once we have everything documented, then we build those object relationships. I have my devices, I have interfaces. Now let's build out the IPAM data. Let's create those IP addresses, prefixes, attach those to interfaces. So we need to actually complete our data model and the way that we represent everything in NetBox to be an accurate source of truth. And then with automation, we want to implement our change management. Again, we start with the documentation. Once we have everything documented, then we can automate. Because once everything is in that database, we have it available to it, it's fully modeled out. This is where it gets fun, because then we can use the REST API. We can pull all of the information that we need. And we can use that REST API with other tools, like we're going to be exploring here in just a minute with Daphne. We can generate configurations from that data. So inside of NetBox, we have configuration templates. So you can use something called Genja 2, which is a very powerful templating engine with Python. And we can build out a template of our network device config, attach that template to a network device, and when we read that template through the API, it populates data, it populates the values so we can actually get our device configuration for every device as needed, on demand. We also have something called configuration context, which is a JSON data representation. For example, if I have a set of NTP servers that every device at this one site should have, I can associate configuration context with that site. And then dynamic inventory. Again, this is a great thing. Anyone here ever used Ansible? Does anyone have a 10,000 line inventory file with every device in your network, all written in text and YAML? Well, that's one way to do it, but we can also use NetBox as our dynamic inventory source. So tools like Ansible can contact NetBox, find all of the devices that we need, how to connect to the devices, pull that in and use that to automate. And then it's also going to give us the ability to run reports, to have the assurance we can start running compliance reports against network devices and say, does my configured state match my desired state or my intended state? So not only for configuration, but I can find out what happened in the network. Are there out-of-band changes that were made? So compliance reporting, very important. And the community is also very important. There are 5,000 plus networking pros that are contributing to NetBox, helping, sharing, helping out each other all day across the globe, with 10,000 plus global deployments and 15,000 plus GitHub stars. It's widely used by network engineers and network professionals and networking teams. And so far, over 11,000 software commits to the NetBox source. If we take a look at modern network automation architectures, we have our network source of truth in the middle. So this is NetBox. Notice everything is revolving around the source of truth. It's not just an accessory to the network, it is what drives our network. So I mentioned before the intended state. We use that intended state to drive the automation. to actually configure the network, regardless of what platform. And then I just talked about using the compliance reports for our state. Well, we can also get our telemetry data from the network and compare that to the intended state. You know, there are a number of partners that integrate with NetBox. And we can check, once again, as I just mentioned, the difference between the intended versus the operational state. And anything that changes, any change request starts, you know, with our operations. For example, our ITSM system. You can see that there are integrations for Jira, Manage Engine, ServiceNow. So in other words, someone creates a change request, that updates the network source of truth, which then drives our automation, our configuration, and then our compliance. So even though we're using something here to create a change, it's updating the source of truth, and that's what drives the network. Now that being said, I'm going to turn it over to Daphne.
Yes.
From Red Hat.
Hello, Daphne Mendoza. I'm the Principal Product Manager covering network automation in the Ansible business unit in Red Hat. So you probably work with Ansible. You work Ansible CLI only, Ansible Tower, automation platform. Okay, cool. Oh, I'm going to talk to you later. Okay, so what's the difference if Ansible is a framework? It's an automation framework, and it doesn't only apply to networking. It applies to servers, to instances in the cloud, applications, SAP HANA. It's very powerful. You don't have to install an agent, and it's very modular. So it goes packaged into a collection where you have the building blocks for it. It will have plugins, it will have modules, so you don't have to program in Python to have the collection, but you have it like pre-canned. It's like a Lego box. Now, what's the excitement we have with the certified integration with Ansible for NetBox is that now you have the ability to integrate with NetBox. You have NetBox in your enterprise network automation, and you have also Ansible automation platform with Red Hat. You can get the support for it. That means that you have a throat to choke, and you can get any request for enhancement. You can also open a ticket if you have a bug. And it can work seamlessly because, as you saw in the previous diagram, once you update the source of truth, you can trigger that automation. So Ansible has the ability to integrate with end devices. Could be a Catalyst switch. Could be also a Meraki router behind the controller. Could be SD-WAN. Could be ACI. Could be Nexus. Or could be a load balancer or a firewall. Could be Cisco or a different technology. But you want to have something that allows to update the integrations after you have that change in the source of truth. So you want to trigger that state, you want to deploy that change, and that change can be done with Ansible. So it has the modules to define the intended state. It has the plugins to drive the automation using the data from NetBox, and it has also this official support, and it's available in two ways. We both work with upstream, with open source community, so you can use Ansible Galaxy, Ansible and the collection as well. But if you want to have support, you can also use the certified collection that is now available in Automation Hub since yesterday. Now, I can pass it to you because that's going to be the demo. I mentioned about the integration capabilities that Ansible has. Could be through SSH, Netconf, APIs. Now we are going to see the example with APIs, and I'm going to send the mic to you so you can continue the introduction.
All right. Am I back on? You hear me? All right. So one of the things that we're going to talk about today, modern networks, we're seeing more and more controller-based networks, right? We're seeing people start to realize the benefit of using controller-based networking, you know, dealing with something that's going to handle the automation for us. But one thing that a lot of people don't think about is we can still use a network source of truth to drive the configuration or to drive tasks on our controller. So now we have our physical network here. We have our controller that is controlling all of the configuration on the network, and the configuration on that controller is being driven by our network source of truth. Our documentation is always accurate. So today we're going to be looking at using NetBox with Ansible for a dynamic inventory, and then using Ansible to pull some information from a Catalyst Center or Meraki Cloud. And this is where it gets exciting. Mainly to find out if the code's going to run on my machine. Oh, before we do that, we need to take a look at NetBox. We've got some things that we've done with NetBox. If you've seen NetBox, or if you haven't, this is our data center infrastructure management. These are devices that we are going to be interacting with. We have a couple of sites. We have DevNet, Cisco DevNet, and the Meraki Sandbox. We're going to be interacting with the DevNet always-on sandbox for Cisco Catalyst Center. And unfortunately, I did not get a chance to reserve a sandbox for a Meraki instance. So we can go through the Meraki code, but I don't have a dedicated sandbox available to me to demo that. But if you notice our switches, our devices here have roles: access, distribution, wireless AP, security. We're going to be looking at Cisco DevNet is where we're going to start because that's our Catalyst Center instance. When we interact with Cisco Catalyst Center, there are a couple of things that we need. We're going to be using a REST API, so we need to know what to connect to. What's our Catalyst Center instance? And also, within Catalyst Center, the intent APIs, we are actually going to be using the device ID that we pull from Catalyst Center to know which switch to configure inside of that Catalyst Center instance. If you notice, these are custom fields. If you have not seen custom fields before, let's take a look at those. So what we're going to do is do customization, custom fields, and you'll see that we have two custom fields defined here. They're both associated with devices. One is called CCC Device ID for Catalyst Center Device ID, and the other was called Cisco Catalyst Center. You can see the device ID is a text field. So that just allows us to enter some text into a field, and that gets associated with the data model. So we're extending that data model for the device with these custom fields. And for Catalyst Center, this is actually a selection. So we have a number of Catalyst Center. We've documented all of our available Catalyst Centers in our network. And we create these choices. So when you select the Catalyst Center, it could be EMEA CCC, America CCC. In this case, we're going to be using sandboxdnac.cisco.com. So again, let me show you those. Let's see, Cisco DevNet. So again, our custom fields, this is the extended data model. We've got our Catalyst Center device ID. So when we interact with Catalyst Center, we can say, use this device ID and do something with it, or give me something for that device ID at this Catalyst Center host. Let's go over here to our Ansible playbook. Here we've got, let's take a look at our inventory real quick before we get in there. I know time is going to be moving by quick. If anyone wants to see this in more detail, then we can speak after the session here. But here's our inventory. So we're using the NetBox NB inventory plugin for Ansible. We're telling it don't validate the certificates right now. And then our inventory, we are going to group it by device roles and sites. Remember the device roles I showed you? We had access, switch, distribution. So we're going to group the data by our device role and by the location of the device. The way that we're authenticating to the NetBox instance, I have a couple of environment variables set here. One is NetBox API that has the URL for our NetBox cloud instance. And the other is, I believe it's NetBox token that has the API token. If we look here at the top, the host that we are going to be interacting with. It says device roles distribution and device roles access. So our inventory plugin is actually going to give us some kind of special variables, device underscore roles, and then we tell it what roles that we want to interact with. So we add the underscore and put the role name after that special keyword. So distribution and access are the types of devices that we will be interacting with Catalyst Center. We have our credentials up here at the top that we're going to use for our always-on sandbox. Let me try to make this a little bit wider. Okay. By the way, this code is in a GitHub repo, and there's a link in the slides at the end of this. So if you join that WebEx space, then you can. The slides are already posted. We're going to set a couple of facts for our playbook run. So the first thing that we're going to do is say Cisco Catalyst Center is host variables for the current host. In other words, the current device, like switch 1, switch 2, switch 3, 4. Dot custom fields. Remember we extended that data model? And then Cisco Catalyst Center was that custom field name. So let's just verify here. Let's go back and we'll show you. So Cisco Catalyst Center, that's the custom field name, and then the other is CCC device ID. So that's where those are coming from. And we're setting a fact for CCC device ID to be the host variables for the current device that Ansible retrieved dynamically from the NetBox plugin, custom fields, CCC device ID. So now we're using that extended data model to set some facts in our playbook that we're going to use in the following tasks. When we interact with Catalyst Center, the first thing that we need to do is get an authorization token. The way that we do that is we call this endpoint API v1 auth token. We send it our authorization header. It's basic authorization with the username and password encoded in base 64, the standard basic authorization. When we post to that API, it will return a token to us, and we need to use that in subsequent API requests to Catalyst Center to interact with it. And we take a look here where the register keyword saves the output from this request and stores it in this variable called login response. The next task, we are going to use the Catalyst Center intent API. So notice where we're contacting, HTTPS, Cisco Catalyst Center, so that's that extended data field, the Catalyst Center instance, sandbox.dnac.cisco.com/DNA intent API, network device, and the Catalyst Center device ID. Again, that custom text field that has the unique ID of that device from Catalyst Center /config. So we're going to get the device configuration for the current device from our Catalyst Center instance. And if you look here, we add this header, xauth token, which is actually the token that we received from authenticating the Catalyst Center. It returned the token to us. So now we're going to use login response, which is our registered variable, and use the value of the token key. So we're going to send that in the header, so our response will be authenticated. And then we're just going to print the device config for each device. Let's go ahead and run this playbook. It helps if you finish the command. All right, whoa. All right, so that went a little bit faster than I expected. But we can see if we look through, it did it authenticated. We get the output of each switch's device config JSON, and we can see we actually pulled the configuration from each one of those switches from Catalyst Center. much easier than people might think. Let's take a look at a Meraki example while we still have some time. Okay, the nice thing about the Ansible inventory plugin for NetBox is that we can pull in more fields. It sets a number of variables for us based on data stored in NetBox. And I'm going to show you one piece of data here. Well, actually, we'll get there. Let's take a look at this request first. The host that we're going to interact with, we've got a playbook here that's going to set the management IP address of an MX device, a Meraki MX device. You can see we have the Ansible cisco.meraki device management interfaces. This time, instead of using that Catalyst Center device ID, when we interact with a Meraki API, and we're going to interact with the device, we identify that using the serial number of the device. In this case, the serial number is going to be pulled in from the Ansible plugin, the NetBox inventory plugin, and it's going to automatically populate the serial number field from the data in NetBox. That variable is available to us using this plugin. So the management interface, we're going to tell it the serial number of our MX device. We're going to tell it interface WAN1. We're going to give it a static gateway IP. And then the IP address says primary IP4. I didn't define that in Ansible. It's being pulled from, it's being pulled from NetBox. So we'll pull that up real quick. It is, was that security appliance 1? So devices, security appliance 1. Notice this is in the Meraki sandbox. Oh, this one actually does have a serial number assigned to it, so this is the information that we would use to interact with the Meraki dashboard if I had the reserved sandbox right now. And there's the primary IPv4 address that will be set on that WAN1 interface. And then once we've run that module, it's set the management IP address. We're just going to use the device management interface info to get the management interface so that we can verify that it's correct and we can display the result. So we're getting it for that serial number and just printing the result. So interacting with modern controller-based networks using Ansible and a network source of truth is easy. It's not difficult, and you saw how fast it was. This is going to help empower you to move your automation to the next level using your network source of truth, Ansible, and Cisco Catalyst Center and Meraki APIs. That being said, thank you all for coming today.
May I chime
Andy,
in?
do we have anything?
A little.
Okay.
I'm going to close it. Slide update. This is how it looks like when you're running it yourself. How many of you work with a team? We made that same question in the Meraki session. How many of you work with a team to manage a network? How do you ensure that all of them are using exactly the same playbook? That's when Ansible Automation Platform makes sense. So if you want to run automation in production, ensuring that everybody is doing the same and centralize the playbook, so the same playbook is run by everybody, that's when Automation Platform makes sense. And if you want to talk about it and take a look at it, go to a Red Hat booth, stay here, we can have the conversation. But we know that network operation is risky. We want to have something that's very consistent, very controlled, and when you can also audit what's happening. So that was it. Sorry, thank you.
And I'm embarrassed to say that Daphne just reminded me that we actually have all of our playbooks also imported into the Ansible automation platform as templates. So get Catalyst Center device config, we have this job template. It was pulled from the GitHub repository. It's using the NetBox device dynamic inventory plugin from the Ansible automation platform. And for the jobs, we can either schedule jobs or run jobs, but we can also see the result. So you can see the output here is just like what we saw in the command line. It was successful. 4 tests were executed against 4 hosts. And again, we see the full output here. So again, I know that we're out of time. If you want to see more, if you want to talk more, come and see Daphne and I after this. I know that we have to get ready for the next session here, but thank you all very much for coming. Enjoy the rest of Cisco Live. Have a great day, and we will see you soon. Thank you.
Thank you.
Test 1, 2. Everybody hear me? I know I'm standing between you and the hot pretzels, and they're kind of my kryptonite, so I'll try to make this reasonably entertaining. So, hey, day 2 of Cisco Live, right? Of course, it's getting toward the end of the day. So let me ask you this. How many of you went to a technical session since you've been here? Yeah, I hope so. And how many of you took exams? You didn't take an exam yet or planning to? Did anybody achieve a new certification in the last couple days? All right, there's still time. But the real question is, how many of you have reconnected with people you haven't seen in a while? And I figured that'd be pretty close to unanimous. It doesn't seem that long ago that we were all sequestered with COVID. And now we get to be face to face. And you can see people on video, but it's a different story when you're actually looking in the eye and have a chance to talk. And that's one of the reasons why I like Cisco Live. It's kind of like the World Cup or Super Bowl of nerds, right? And you just get a chance to really enjoy yourself and connect and all the sort of stuff that's going on. So my name is Joe Reinhardt. I'm actually the team lead and delivery manager for Cisco Training Boot Camps. I'll say more about that later, time permitting. This is JC Lambright. He's my associate and co-presenter. We're going to talk to you today about, drum roll please, transit routing. All right. So one of the things to keep in mind is if you want to communicate with us at all, you've got the WebEx client, so you should have been added to the space. If you have any questions, let us know. Even after the conference, I tend to monitor those things for a while, so anything that comes up, please feel free. All right. If I don't have an agenda to follow, I will talk about everything under the sun. So for me, this is to kind of keep all our topics straight. We're just going to do a brief introduction. We're going to talk a little bit about the mechanics of L3 outs and transit routing. And then JC is going to go into some of the details about sometimes things that get misunderstood or misapplied about transit routing and set you on the straight and narrow path, and then we'll kind of wrap up. And so any questions that you have as we get toward the end, feel free. Everybody with me? All right. So to start off, transit routing. Even before we get to that, how many of you would agree with the statement that ACI behaves differently than a regular network? Yeah. When I first got into ACI, I swore it stood for a lot of confusing information because it broke every rule about networking I knew. And I started with networking in like 1998, where things were proverbially simpler. But then this whole ACI thing comes along and it looks like everything got turned on its ear. So it can be a little disorienting when you first get used to it. But because of that, some of these other areas can get a little challenging as well. Transit routing has been supported since version 1.1J to be specific. But now, it doesn't require a lot of, you don't have to have any special software. You just have whatever the latest code is. And we're up to 6.0 something now. Okay. Yeah, I know. We're just about up to 6.1. It took a while this go around, but But sometimes there's misconceptions about how transit routing operates, so we'll talk a little bit about how to dispel the myths, make sure you've got a good understanding of some of those things. And the goal of this session is to help you better understand sort of the nuances of how all this stuff works. I wish I could say we will wave a magic wand and you'll always have the answers from now on, but it doesn't work that way, unfortunately. And we'll be available after the session, and even after Cisco Live, we'll keep monitoring the space. All right. So, L3 outs, transit routing. And JC, you wanted to
sure.
speak to this?
Yeah.
I will hand you the all-powerful clicker.
Oh, thank you. I appreciate it.
And I will stand off to the side.
All right, so before we go into transit routing and what it is, we want to talk about what it's not. So first thing, we have normal internal ACI routing, one bridge domain to another bridge domain. But when we talk about transit routing and what I'm fixing to describe here, internal BDs to the external devices, we're talking about routing that happens at an L3 out. So before we go into transit routing, what you might be familiar with here is routing from an internal bridge domain like an endpoint. And here in my demonstration, we've got an ACI fabric. We've got 3 endpoints. These endpoints are all living on a single internal bridge domain. If they want to route out to an external endpoint, maybe even the internet or something that lives outside the fabric, meaning it's not a leaf or a spine, they need to exit a layer 3 out. So you can advertise normal bridge domains out of an L3 out to an external routing device in a way that you're probably familiar with, where you associate the bridge domain to an L3 out, and then you actually put the subnet on the bridge domain, and you start getting that advertisement out of it. That is not transit routing. That is internal to external ACI routing. Any questions on that? So that's what you're probably familiar with. Now I'm going to bring Joe back up here to explain what transit routing is, and then we'll follow up with some misconceptions.
Tag. You're probably expecting a big, thank you, like a wrestling match after that. No, he'd probably win. No, but as we get into how transit routing works, it's helpful to talk a little bit about what's going to go on with just your traditional routing. So, simple fabric, right? 3 controllers, and we've got this outside device. L3 outs. You have the configuration components. What protocols are supported? Hit wink, wink, nod, nod. They're on the screen. You've got OSPF. You've got EIGRP, BGP, static routes. What's not up there? ISIS. What does ISIS do in ACI? Yeah, that's your underlay routing protocol. It's doing all the heavy lifting for building tunnels and all that wonderful stuff. And to my knowledge, unless you know something about the BU, I don't, RIP routing has never been an option and never will be. But these are pretty much the options for doing routing. And it's pretty straightforward. To do this, you have to identify a switch you're going to use for your L3 out. So it's called a node profile. And in ACI, you've got node numbers that you're referring to more than you do actual host names. So let's say this is leaf 104. So you'd have a node profile for 104. Then you're going to identify the interface on that switch you're going to use. And for options for interfaces, you have routed interfaces, my personal favorite because they're simple, routed sub-interfaces, and then you've got SVIs. But any one of them will work. The reason I like the routed interface better is you don't have to go through and create the VLAN pool and all those other steps. You can just put the IP on the interface and you're done. But it really does come down to how your network's designed. And if you're going to change any default routing behaviors, you have to have an interface profile, an interface policy profile. So for example, OSPF, you want to do the Nexus equivalent of IP OSPF network point-to-point, you've got to do that in a policy profile, otherwise it's going to default to the whole DR-BDR thing. So, but these are all the things that you would need. And then the final step is you define your external EPG, where you tell ACI which one of those networks, those subnets that you have, are that are going to live out here so it knows where they are. All right. So a couple of things. In this diagram, you've got 2 different OSPF peers. They are not a part of the same area or process or anything. OSPF Peer 1 is running one process, OSPF Peer 2 is running a different process. They're not talking. And here, routes are going to be redistributed on the border leaf, so this 1122 is being redistributed into BGP, multi-protocol BGP. It gets sent up to the route reflector, so the rest of the fabric knows about those routes. And the same thing's going to happen here in the other direction. Routes learned, shared with route reflector, propagated. So when you look at the routing tables on leaf switch, this leaf switch and that leaf switch, you're going to see those routes. But what you don't see is those routes coming out the other side here. That's what transit routing is. And when they are redistributed back, they'll show up as like E1, E2 routes or whatever you have on your, if you're doing just regular external routes. Simple, right? And as I said, this is how the whole process is working as far as sharing routes. But the biggest thing that's happening is those routes are not being shared going back out. They're blocked. This is the default behavior for ACI. It used to be hard-coded that you couldn't use this as a transit area. But for this to work, for transit routing, for routes to get passed back out the other side, you have to have a special configuration to do that. It's not automatic. How do you do that? I'm glad you asked. So there's two primary methods for doing it. The first is an export route control subnet. This was the first available method. And the last step in doing an L3 out, you're doing your external EPGs, right? You're listing out all your individual networks. There's another checkbox in that screen that says export route control subnet. And what that means is that this leaf switch realizes that it's okay to take whatever networks those are and advertise them back out this way. And you have to do it for both of these external EPGs. And that's where the configuration is done using this method. It's pretty simple, and again, it's been around the longest, and it's configured under the same screen as the external EPG. There is another method. It's the preferred and best practice method. Best practice is probably what they're saying these days. Yeah, it's ultimately your preference, but it's usually what's recommended. And it's called a default export route profile. This is the ACI flavor of route profiles. And instead of using the external EPG to define all of this, you're using prefix lists to define what routes you want to permit back out the other side. And it is the recommended method. So for transit routing to work, you have to go through one of these two, and then when that happens, the 1.122 would show up in the routing table back here of this device. And then you could theoretically, ping back and forth. But there's more to that than I know you're going to be explaining, JC, because just because you can see the routes doesn't mean the traffic's going to flow. Now I'm going to hand it over to you. I should have advanced the slide.
Right. All right, thanks, Joe. I appreciate that. All right, so one thing we want to talk about here is when we go into the external EPG, sometimes I even call it an L3 EPG to kind of remember it's part of the L3 out. What you would think of as a normal EPG would be attached to a bridge domain, and we might consider that more of an internal or an L2 EPG. But under the external EPG, and it looks a little different now. If you've been working with ACI before version 5, some of these checkboxes at the bottom and at the top used to all be together. But I'm not sure why we did this, but we did this. So the piece that you want to understand here is that even though these both fall under an EPG, and we think of an EPG as related to policy and allowing data flow packets in and out, we don't really think of it as related to routing. But for the L3 out, we have this route control section here in red, and then we have this blue policy section at the bottom. So this is the part down here, this policy section, that you would typically think of as being in an EPG. You're classifying things into a security group, you're managing contracts, all of that. But this top section here has to do with route control. And when we say route control, what we mean is if I'm being advertised a route, either via BGP, OSPF, or EIGRP from an external device into my border leaf, that has to do with route control. It has nothing to do with packets. But I've worked at ACI for going on 9 years now. And starting out, I was a customer, then I moved to a partner, and then I've been at Cisco for the last few years. So I struggled with this concept, and it used to not even be as good as it is now on documentation. So this is part of the reason we wanted to come and put this presentation together and try to make sense of these two different parts. All right, so when we say route control, we have routing that goes in two ways. The border leaf is accepting routes from another routing device. That could be a firewall, it could be a router, it could be a layer 3 switch. Like it might even be info blocks or something else that routes. It's accepting routes in. But the border leaf is also exporting routes out to those devices. So Joe talked about a while ago these export route control subnets, and below it we also see import route control, and it's grayed out. So as he was saying, by default, ACI does not export any external routes out of another L3 out. So if I learn a route on L3 out 1 on one leaf, and I want to advertise it out L3 out 2 on a different leaf, that doesn't happen by default. We have to check this export route control subnet box or use that default export route map that he showed us on the previous slide. But let's talk about why we're separating these for a minute. So if I go into my command line in ACI and I do a show IP route and whatever VRF that we're in, the tenant and the VRF, I should see all the routes local that exist on bridge domains. But I'm also going to see the routes that were imported to me from local L3 outs. If we check this export route control subnet here, it's saying, do I want to advertise the routes that I learned on another L3 out of this one? But we could also do it through the default export. But let's say we come in here, we do the show IP route on the routing table, and we see a route to an external device, but we try to ping it, and it doesn't work. We have no access to it. The ping just fails. Or we try to initiate a connection out to the internet, and it doesn't work, but we see the route for it. So what's going on? And that's where we get to these two different things. I could have this set correctly, and I could be importing and exporting my routes, but I might not have the policy set correctly, and it would be blocking the data plane. So it's like a strange distinction that they're both in the same spot. But this works on routes, this works on policy, and you can have one set correctly and be able to ping through and one not. And that's like the hardest piece of transit routing is understanding that these two are different, I think. And then if we look down here, you're familiar in the EPG here, the layer 3 EPG, that when you put a subnet in and you either check export route control or you do the external subnets for the EPG down there, we see them come up here and they have a scope. The scope has to do with either route control or policy. And I've highlighted the blue over here to equal policy and the red to equal the route control. And if you look here, this quad 0/0, most people are probably familiar with that in ACI and L3 outs. That has nothing to do with my route control, because if I look here, it's external subnets for the EPG, not export route control. So what we're saying, if we look at these lines, is this quad 0, if I see anything with any IP come in this L3 out, make it part of this layer 3 EPG. But these next three statements, what they're actually saying is, the first one there, it's IP address 1.1.2.2/32. If I've received that route on another L3 out, it's okay to advertise it or export it out of this L3 out. And the same for the other two as well. They're both /32 routes, but we could do this with a /24 or anything like that. Commonly, though, you see this quad 0 being used as both export route control, so saying advertise anything I've learned on another L3 out, and you see it also being the external subnet for the EPG. So you might see that, I don't know, maybe 80% of the time probably, but there are cases when you don't need that. In some cases, you don't want to advertise anything you learned out. A good example is, let's say you've got mainframes connected to your ACI fabric. You have maybe a mainframe connected on OSPF on one L3 out, another mainframe on another L3 out, and they might need to advertise their routes between each other, but you might not want to advertise those mainframe routes out to the internet. So that's some of the reason that you might control your routes. The other piece that we should talk about here is import route control. So if I have an L3 out and I'm peered up, my BGP peering, my OSPF peering, my AGRP peering, I'm peered up with a remote device, and I want to import the routes from that device. What's the default behavior in ACI? Does anybody know? If we're importing routes from another device, are they blocked? Do we allow them all? Okay, so import, if you notice it's grayed out there, there's a reason for this. It's actually almost a double negative. So at the VRF level, there is a box to turn on import route control. So by default, the importing side of external routes is turned off. And because it's turned off, that means we allow everything, which is almost that double negative of the feature is disabled, but it allows everything because it is disabled. But the mainframe is also a good example, and there's actually somebody here in the audience that I helped with on the CX side with this. They had a mainframe, and the mainframe, let's say it had 25 routes. It was advertising into the fabric. It was paired up with OSPF. If you're not familiar with mainframes, they usually run OSPF on their own internal network. Well, this OSPF mainframe was advertising routes into the fabric, and they had 25, 30 routes, I believe, coming in, but they only wanted ACI to learn 10 of them. So they were one of these rare examples where we went into the VRF, we enabled import route control, and then we came here, checked this box, and we spelled out all the subnets that we wanted it to import. When you turn on import, it's like a whitelist only. You have to spell out every single subnet you want it to import. And then the last box I think we should talk about here is this aggregate box. Once you select import or export route control, the aggregate box will become black. You can then check it. It's no longer grayed out. I would say it's really useful in certain ways, but when you click that aggregate box, what it actually says is, if I don't click the aggregate, if I just put export route control and I put like this subnet here, it will only export that subnet if it matches exactly. So meaning if I have a route in my routing table that has a /32-bit mask, it will match that subnet and export it out. But if I click the aggregate, I can then use the quad 0, and it will say any subnet I have from 0000 up to 255, 255, 255 with a /32-bit mask, then I can advertise it out as the aggregate. And that's why you typically see export route control and aggregate clicked together. All right, let's move along to another misconception. And just to kind of recap here first, the route control does not affect contracts, and it has to do with the control plane, your actual routing. The policy down here at the bottom, it affects data plane. And this is where you need your contract to allow endpoint-to-endpoint communication. All right, oh, I forgot I actually had a slide for aggregate export. So we talked about it beforehand. But this is the box that you would allow to, or that you would check to allow all the quad 0 routes to be exported out. So if I were to check that export aggregate box there and put this in, it would allow all routes to be exported. All right, special case here. If you've worked with multi-site, we have a feature called inter-site L3 out. You typically have this where, let's say you have a data center, they're both connected to the internet and they're kind of backups for each other, but both data centers running active at the same time. Well, what if your internet connection goes down at one data center, but it's still up at the other data center? You can use this inter-site L3 out feature so that traffic from one might cross the ISN into the other. But because we're talking multiple L3 outs, there's still a transit routing component to it. And when you combine these L3 outs, even across multi-site, we still have export and import route control meaning the same. So if I learn a route in site 1, it will not get exported out the L3 out on site 2 unless I set up export route control. Again, this is kind of a corner case. You don't see this very often, but if you have multi-site and you're running inter-site L3 out, transit routing applies exactly the same as it does in a single fabric. For multi-pod also, same thing. One of the pieces we also didn't touch on earlier is that we all know inside of ACI, it's running ISIS and it's running protocol BGP. So another corner case that's actually spelled out quite well in the L3 Out white paper is whenever you import routes, let's say your L3 route is running OSPF, you import the routes in OSPF, ACI then redistributes those into multi-protocol BGP to move across the fabric, and then it gets redistributed back into whatever protocol the other L3 out is running. So there are a couple of corner cases with OSPF if you have your L3 outs on the same leaf. They actually redistribute right between each other, and they never go into multi-protocol BGP. But if you ever run into those, just check out the L3 Out white paper, and it's going to detail them in a lot more time than we have today. Also, the Intersite piece, it requires an external TEP pool, which is something you actually configure on Nexus Dashboard Orchestrator, and it needs a contract between the L3 outs at both sites. But then the transit routing works exactly the same. I'm going to hand it back over to Joe.
Thank you.
Thank you, sir.
So one of the points that JC was just making is important, is if you've got routing, like in those two OSPF examples, you can see all the routes over here, and you can see all the routes over here, but you don't have a contract between, you're not going to have any traffic. Contract rules still apply between external EPGs. We can kind of think of contracts a lot between internal EPGs and maybe an internal EPG to an external EPG, but it still applies to external to external. So if you have all that together and then the traffic's not going through, check and make sure your contract is configured. It's the sort of the underlying rule for all of that. So as we wrap up, transits routing is used in L3 out. So if you have multiple L3 outs, 2 or even 3 or more, you have to enable transit routing for it to work. It's been around a long time, and then advertising routes learned from one external source to be advertised back out the other site requires these to be configured specially. I mean, the leaf switches will have all the routes, but it's not going to advertise them back out. Route control defined how they're shared, and policy packet and flow, this is the whole contract piece where you're allowing what traffic's going to go. And we're still going to be available here after the session. I made sure you had top billing, by the way. Because this is not, like one of those topics that may keep you up at night, but I guarantee you if you run into some of the issues on this, you're going to want to know the answer on this. So this presentation is supposed to be made available through, I'm not sure which mechanism it is. Do you know where the... Okay, that's, yeah,
I don't know when, exactly.
Because the Cisco USS sessions are listed just like other sessions in there, so there should be a session presentation that you can download. I have not had a drop to drink, I promise, but it's late in the day. So any other questions before we wrap up? If the question is the pretzels, they're right over there. Yes, ma'am. Can you, I can't.
Go ahead. Yeah, so thank you. So the contract would be a separate piece. So what we showed there in the L3 EPG, that's showing how we classify packets coming in, like into that L3 EPG. And it's also showing the routing piece. But you would still need to go to that L3 EPG and go to the contract menu and apply a contract one direction. So you would need the contract between L3 out 1 and another contract on L3 out 2 to allow that communication to pass through the L3 outs. Because remember, transit routing is just what it sounds like. It's using the fabric as a transit for other traffic, meaning something's coming in, but it's not destined for an endpoint in ACI. It's destined to go out of another L3 out. So you would still configure a contract, but you would do it under the other section of the L3 EPG on both sides.
All right.
Does that answer there? Sure.
Any other questions? Well, thank you all for coming, and I hope this is useful and fun, and you've got a lot less left this week to enjoy. The CCI parties tonight, for those that are CCIs who got that. Customer events tomorrow, and obviously there's a lot going on in World of Solutions. So thank you very much. Thank you, JC, for helping present on this.
Thanks, Joe.
And you guys have a great rest of your Cisco Live.
Yeah, appreciate y'all coming. Thank you.